welcome to the WeAreDevelopers Live Week 3rd edition. And 3rd edition means it's number 3. And if you're interested in number 1 and 2, you can find them on our YouTube channel. By the way, if you are watching this live stream either on YouTube or Facebook, please go to wearedevelopers.com/live-week. You will find more information like the agenda and also stuff like Slido, our tool which makes Q&A interaction easy cheesy. So, you know, this is 2020 and usually we would be meeting in the Hofburg in Vienna for the Vienna Congress 2020, but we cannot be here. But we thought we bring a little bit of this Vienna vibe into this live stream. So this is why we welcome our partners, the Vienna Business Agency and the City of Vienna. And also our partner of the day, Couchbase. So, as you can imagine, there are a lot of people involved in creating a live stream like this. So we also want to firstly say thank you to all our main partners and also the partners who said that they would like sponsor 1 or 2 talks, and also our media partners who always help us to spread the word. And last but not least, the community partners, which are always there for a good discussion, good advice, and also content pieces. So today's Monday, it's the data day, and everything is about what to do with data and how to work with data. And you already missed the workshop this morning, but enough said about us. Let's talk about you. At the moment, there are 89 different nationalities among the participants, and there is also the thing that if you are on the webpage wearedevelopers.com/live-week, you just go over to this part of the screen and you will find Slido, and you can use it to participate in polls. At the moment, there is a poll running about where you come from, and you can also use that to ask any questions while the talks are going on. Q&A means that most of the questions will be answered after the talk. There is also a nice side program. So if you know of any kids 9 to 16 years of age, there is also a Coding for Kids live online workshop together with Da Vinci Labs. And if you are also like planning on visiting Vienna for this talk, then you will also find some touristy stuff like on Wednesday, where you will have the chance to get a guided tour through the Albertina Museum. Before we start and I push you into the program, let me talk about the code of conduct. And the code of conduct is more or less simple, the rule where we say how do you want to interact with each other. The short version is be nice and treat each other with respect. And the long version goes something like this. So, now it's time for the welcome remarks by the Austrian Federal Minister of Digital and Economic Affairs, Margarete Schramberg, and after that we will also get welcome remarks by the Vice President at the Austrian Federal Economic Chamber, Amelie Groß, and I would say, let's see what they have to say.
Sehr geehrte Damen und Herren, ich freue mich sehr, auf diesem digitalen Wege bei der WeAreDevelopers Week dabei sein zu können. Mir ist es wichtig, die digitalen Kompetenzen in Österreich auszubauen, denn 90% aller Berufe setzen heute digitale Grundkompetenzen voraus. Es ist wichtig, dass wir uns auf dieses Thema gemeinsam konzentrieren. Die Covid-Krise hat uns gemeinsam in die digitale Zukunft gebeamt. Viele Dinge sind jetzt möglich, die vorher undenkbar waren. Viel mehr Homeschooling, viel mehr Homeoffice. Aber auch im Bereich der Innovation wird die Covid-Krise einen wichtigen Input haben, ein wichtiger Treiber sein für Innovationen. Digitale Innovationen, die digitale Transformation der Unternehmen steht im Mittelpunkt der Entwicklung. Und das gilt nicht nur für große Leitbetriebe, sondern auch vor allem für KMUs. Startups und innovative Developer spielen hier eine wesentliche Rolle. Sie sind Taktgeber und Treiber für diese digitale Transformation auch des österreichischen Mittelstandes. Aus diesem Grund habe ich eine Allianz für digitale Skills und Berufe ins Leben gerufen. Es ist wichtig, dass alle Ministerien daran arbeiten. Allen voran natürlich mein Digitalministerium gemeinsam mit dem Bildungsministerium, aber auch mit dem Arbeitsministerium, Innenministerium und Verteidigung. In allen Bereichen ist es wichtig, dass wir vor allem mit der Europäischen Kommission zusammenarbeiten und hier die digitalen Kompetenzen in ganz Europa vorantreiben. Wir haben dafür in Österreich einen Aktionsplan für ein digitales Österreich. Hier gibt es viele Projekte, die wir gemeinsam vorantreiben. Es geht darum, die Gesellschaft voranzubringen und die digitale Lücke zu schließen. Covid darf nicht dazu führen, dass der Digital Divide in unserer Gesellschaft weiter aufgeht. Wir müssen alle mitnehmen und gleichzeitig Spitzenskills und Spitzenkompetenzen entwickeln. Cybersicherheit spielt für die digitale Transformation eine ganz wesentliche Rolle. Sich sicher im Internet zu bewegen, ist für alle in Österreich von Bedeutung. Entwickler spielen auch hier eine wichtige Rolle. Ein hohes Maß an Cybersicherheitskompetenzen in Österreich führt auch dazu, dass unser gesamter Standort resilienter ist, nicht nur die Unternehmen alleine. Mir ist es wichtig, dass wir die Themen in Österreich vorantreiben für Gesellschaft, Wirtschaft und Verwaltung. Daraus entstehen zahlreiche Projekte, wie zum Beispiel das digitale Amt, Amtswege mobil in Anspruch nehmen zu können. Immer dann, wenn man möchte und immer dann, wann man es braucht. Hier ist der nächste Schritt, eine Plattform zu schaffen, in der der Führerschein und andere Ausweise digital auf mobilen Endgeräten verfügbar sind. Ich wünsche euch eine spannende WeAreDevelopers Week, viel neues Wissen, spannende Kontakte und dass ihr viele Projekte umsetzen könnt, die den österreichischen Standort voranbringen.
Dear developers and tech-minded guests from corporates, scale-ups and startups, welcome to the 2020 Live Week WeAreDevelopers. I would have loved to speak to you in person today, but I'm very happy that I can send you this video live from our headquarters here in Vienna of the Austrian Federal Economic Chamber. 2020 has challenged all of us. And this year really has been unpredictable. But times of crisis are also times of opportunities. And this pandemic pushes us to be even more creative and innovative. Some weeks ago, I had the chance to kick off the WKO Coding Day. Many young people and students participated in this event. And those kids are our future developers and future digital workers. I'm very happy that you as our senior talents are coming together online this week and rethinking business models, and having nice and cool ideas. If you're thinking about going global and expanding to other countries, the Austrian Federal Economic Chamber has more than 100 offices around the world. So if you need anything and if you have a question, just give them a call and they're happy to help. I hope that you enjoy this week and take as many inspiration with you as you can. And for those of you who are participating in the online live pitching event, Scale-Ups to Corporates, I wish you all the best and good luck. And I hope that all of us can meet in person next year when we come together for the event 2021. Goodbye.
Hello. Hi, Steffen.
Hi, Stefan.
Good to see you again. I hope your lunch break went well. And yeah.
Yes, it was. Hope you too. So, let's kick it off. Welcome everybody to the start of the extensive sessions on sessions here in day one. Data Works from WeAreDevelopers. My name is Steffen Schneider and I'm at Couchbase, the head of solutions engineering for the Central Europe region. And this day is in fact sponsored by Couchbase, a modern data management system. So Couchbase is based upon NoSQL technology, has a global footprint, and is also based here in Central Europe with a Manchester and a Munich office. So you see at the right-hand side the market adoption, not only from the company, but for sure coming from its product Couchbase itself. And this product serves mission-critical and business-critical applications across all the verticals you can see here. So it is really vertical agnostic. And also we are here not only in labs, but well known in all market leading companies with mission and business critical applications. What the system actually does is it provides to you the best well-known expectations from the RDBMS world, kind of SQL asset transactions, for example, and combines this with all the advantages of NoSQL technology in a distributed fashion, and also with cloud, without the demand on being always in the private or public cloud. So basically it is infrastructure agnostic, and you can deploy all the data management services you can see here in the colorful tiles in every single deployment mode you like. So that being said, and I want to give you another important hint. What's in it for you when saying Couchbase is the sponsor? You actually can click on the WeAreDevelopers Live Week homepage here, this button, and you have the chance to be the winner, 1 out of 3 winners, gaining a potential 200, so 200 euro Amazon voucher. And all what you need to do for this is just enter your contact details and you are in the game and can win this great prize. Coming now to our own session, database on Kubernetes, why you should care, with my colleague Dennis Rosa. So hi Dennis, how are you?
Hello everyone, welcome. Thank you for having me today. How are you doing, Stefan?
I'm doing fine, thank you. Dennis, you also, I know. And guys, what Dennis will show you in a hands-on fashion way is the point how we can operate in the microservices infrastructure from a development perspective for sure, and the major point here, without database burdens, which you typically know from the RDBMS world when you want to transition over to the more agile containerization. You face here limitations, which is no longer the case. And Dennis will show you the hows and the whats. So I hope you enjoy. Dennis, you can start, and I will feed you also with questions coming in. So we try to make this session as interactive as possible.
Sure. So thank you very much. Well, welcome guys to Database on Kubernetes. My name is Dennis Rosa. I work as a developer advocate at Couchbase. One thing that Stefan forgot to mention is that we are still hiring, and we do have a lot of open positions. So yeah, feel free to reach out to us if you are interested in one of these positions, especially on Central Europe as well. And well, coming back to the talk, first, I would like to introduce myself. So I work as a developer advocate at Couchbase. I have been a software developer for over 15 years. The majority of them working with NoSQL and Java. And I also contribute to a lot of open source projects. So feel free to reach me out if you have any questions. Okay, so I would like to start with a small tip for you guys. Whenever you are reading an article online, if the article starts with a question, in 80% of the cases, the answer will be no. Just as an example, those are all real articles from very famous websites in 2016 saying, hey, should I run my database on containers? And as you can see, they all are questions. And the answer for all those questions, all those articles were, no, you should not do that at all. Back then, the main argument was that containers, they were designed to be stateless. And yeah, that's still true. It still holds. Containers, in fact, were designed to be stateless, and databases are well known to be stateful applications. However, if we fast forward to 2020, you see that in fact, you can even see articles dating from 2018 saying running database in Docker at scale. And as you can see, the articles nowadays talking about database and containers, they are not questions anymore, because this is already a well-known. This is already well-known in the developer community that yeah, you should run your database on Kubernetes. So it's interesting to see when you are on IT and you see this changes, those opinions changing. And the natural question here is, okay, what have changed? Why in just 2 years we completely changed our mind and we came from no, you should not run your database on containers to yes, and here is how you do it at scale. Of course, the answer for this question is very long, but one thing that I can say is, first, we had a bunch of improvements on Docker when it comes to performance. Mostly in the last, I would say, 2-3 years, we had a very good improvements there. Now, all database vendors also have production-ready images. Of course, it's far easier to configure and set up a database using containers versus installing this on bare metal. You can separate storage from compute, which is something really good when we are talking about big data in general. And of course, Docker containers are just half of the story. We still need someone to manage those containers, and that's where Kubernetes and stateful SaaS kicks in, which is one of the main topics of this talk. Okay, so let's say you want to deploy MySQL on Kubernetes, for instance. The standard way to do that is, okay, let's reference an image here. In this case, MySQL 5.6, and then you create a deployment, and you expose this as a service. This would be like the most naive way to deploy MySQL on Kubernetes. The problem is that's not exactly how we do in the real world, right? Because databases are highly configurable applications, and if you really want to use this inside containers, you have to create different images every time you change something. And at the end of the day, you might end up with multiple different images, and you have to guarantee that all those images, all the databases running on inside your cluster, they're running the same images. Okay, the other problem, of course, and then naturally the problem is, how do I manage the configuration on Kubernetes? Should I use an external service, or is there something inside Kubernetes to manage configuration? So that's the problem one. And with that, I would like to show you guys my first demo. What I would like to do here today is, I have a tool. Oops. Let me go back to this page. Okay. I have here, this is an IDE called Lens. It's very user-friendly for those who are not familiar with line command or CLI in Kubernetes yet. And you can essentially navigate through your cluster using just this IDE. So here I have 3 nodes running. I have one Kubernetes cluster with 3 nodes. And essentially what I would like to do here is, in Kubernetes, there is something called custom resource definitions. So custom resource definitions are, so Kubernetes come with some default types. Like let's say, for instance, we have pods, we have deployments, service, and so on. And you can extend, as Kubernetes is very extensible, you extend Kubernetes and create your own types. In this case, I'm adding a to-do here. And then I'm just, this is just the syntax that I have to use, but what it really matters here is, hey, I'm adding a new type called to-do, and the plural here is to-dos. So I can copy this, come here to Lens, and just here and go to create resource. I can paste the whole thing and hit create and close. This, if you are familiar with Kubernetes, this will be similar to run something like kube control, create let's just, it would be similar to run kube control, create -f, and then the name of a file .yaml. So what I'm doing here, I'm just copy and pasting the whole thing inside this IDE, because, okay, it's easier for those who are not super familiar with Kubernetes. Okay, now that this will be similar to creating a table, essentially, if we translate this to a web developer language. And then we can insert data inside this YAML file, or add insert a new row inside this custom resource definition. Here is just an example of a talk that I spoke this Saturday. And essentially I'm saying, hey, here's a type called to do. And then here's the name of the task, and here's the date. So if I copy this and come here, create new, create resource, and paste here, and create and close, then I will create this new type inside Kubernetes. Why this really matters? Because now I can actually, I can actually come here and hit kube control, get to-dos, and it will list exactly what I inserted there. Or if I run kube control, describe to do, and the name of the to-do here, I will essentially see the whole content of the row that I inserted. What really matters here is that I can come here on custom resource definitions, and at some point, in fact, if I come to definitions and click on to-dos here, which is what I just inserted, I can see here speak at NoSQL BR, and you can see the whole data, everything that the whole data that I just inserted. Cool. Why this is important? Why should I care about everything that I did here? Because I'm essentially using Kubernetes as a database, right? Well, because I can create a specific type, let's say Couchbase cluster, and then insert the whole configuration of my database there. So I don't need to use any external tool to save the whole configuration of my cluster. Cool. But now let's go back to our MySQL example. So say I really want to deploy MySQL using the standard Kubernetes resource, which is just deployment and services. And if you apply this configuration to your cluster, you will end up with something like this. So I have a MySQL with a volume attached running inside a worker. So, or a slave, each, there's not a specific naming yet, but we have a master in Kubernetes and workers, which is the three workers that I showed you today. Okay, so if I apply this YAML file on Kubernetes, I will end up with something like this. However, of course, if by some reason the worker goes down, let's say due to some hardware failure, or the cloud provider decides to update your node from Kubernetes, I don't know, 17 to 1.17 to 18. What will happen here is essentially, okay, you will lose your whole, your database will be unavailable because you lost your database. That's okay. No big news here. We all know that, okay, I should not trust in a database running in a single node. And then you decide to deploy 2 MySQL instances, right? So now you have 2 MySQL instances running with 2 volumes attached, and you're good to go, right? Well, not really. If you're not aware of what interpod and affinity means, you might end up with the same thing here. Like, okay, yes, I do have 2 instances of MySQL running, but for some reason, the scheduler inside Kubernetes scheduled those 2 pods to run inside the same worker. And again, if the worker fails, boom, your database isn't available again because they were running inside the same, physically inside the same node. But even if you configured everything right, and we still have here, and now we have 2 instances of MySQL, one running in a worker 1 and one working in a second worker. If, let's say, the worker 2 fails, that's okay. You still have your database available here. But Kubernetes will bring this node back, but this pod back, in fact, we will deploy this pod again. But again, remember that databases are stateful applications. And this node here will come back empty. And because it is empty, it's also, one, has no data in it, of course. And second, it has no idea that it has to run in a cluster. So even though we brought this node back, there's no replication or whatever we have configured between those 2 MySQL instances. So you see, it's still, okay, we solved one problem, which was bringing the application back, but because databases are stateful, there's still a bunch of stuff that we have to do in order to make this cluster healthy again. And it kind of looks like that something is missing here, because, okay, yeah, we solved just half of the problem. And yes, there is something missing here. So the second problem is, how do we manage state in containers, right? Because the reason why your application is stateless is because you push the state to the database. And the database here is it has to run in a cluster, and once you bring something back, you have to recover the state. Okay, and here is one of the advantages of using CRDs, which is what we created before. So when I have my whole configuration inside a CRD, whenever something changes here, let's say I changed the bucket, let's say the server from 3 to 4. So it will trigger one event inside Kubernetes. Kubernetes is is an event-driven application. So when something changes in the CRD, let's say I deploy a new version of my CRD, it will trigger an event internally on Kubernetes. And one of the cool things in Kubernetes is something called operators. So operators are essentially applications that you can deploy inside Kubernetes that will listen to those events. So let's say, for instance, I want to listen to, okay, whenever a pod dies, I want to listen to this event. And according to the type of the pod that died, I could take some action. Or let's say if I updated, there is a new update in the configuration, I could also listen to this event and take some action internally and call the Kubernetes APIs to maybe start a new pod or configure this pod. And essentially what allows me to do, in this case here, the operator is stateless. So it saves the state. It saves the state on etcd. So etcd is a database that exists inside Kubernetes. So even if the operator dies, Kubernetes can bring the operator back. It will naturally bring the operator back, and then it will recover the state from etcd. So it is naturally highly available because of this. And of course, the operator will, it is application specific. So I can build an operator for Postgres, for MySQL, for Couchbase, for whatever other applications you have in your cluster. You can create an operator for it, or you can use some community developed operators, or you can just use the one that the vendor offers you. In this case, Couchbase was pretty much the first database to release an official operator, because we started creating an operator roughly 2.5 years ago. And that's why it's a very stable product right now. So essentially, when I deploy the operator, the cool thing about the operator is that it will listen to all events happening in this case, in a Couchbase cluster. And because the operator is an application developed by humans, of course, we can insert a lot of knowledge inside the operator. So for instance, well, if a Couchbase node dies, there is some very easy steps that you have to go through in order to recover from this cluster. Recover this cluster and bring back to a healthy state. So you can insert this logic inside the operator to automate this whole recovery process. Or let's say I need to upgrade from version 6.6 to version 7. So I can automatically, when I apply this change, the operator knows exactly what are the steps that I have to go through to upgrade from one version to another. And the reason why this is so powerful is because I essentially can create a database as a service solution inside your own cluster. So I don't need to go to a cloud provider and hire database as a service solution there. I can still deploy everything inside my cluster and have pretty much the same experience that you have when you hire the best solution, but with much more flexibility, of course. And that's exactly the demo that I would like to show you guys today, because and everything that I'm going to show here is live, because you only live once, right? Okay, so let's go back to our example here. And here, again, as you might, if you just joined this talk, we have 3 nodes. And here I have my pods. So essentially what I'm going to do here is I have Couchbase clusters here. I'll just copy this whole thing. I will explain in a minute, and paste this here. So I come here, create resource, and paste here, and boom, create my Couchbase cluster.
Maybe Dennis, let me briefly jump here in, because I know that there could be the possibility of coming in lots of questions for the interesting part we are seeing now, the demoing part. I just want to emphasize, guys, that you have the possibility to always insert or putting in questions coming from your side over the WeAreDevelopers Live Week portal, where you actually see this here as a live stream. You have there at the right-hand side a window where you can insert your questions. Yeah, so please feel free to do that. The more you ask, the more it gets interactive. So Dennis, go ahead.
Thank you, Stefan. So guys, just to save time here, I already deployed the operator. So we already have here the Couchbase operator running, and the Couchbase admission controller. So the operator is something that you just download from Couchbase and you'll apply inside your cluster. Same thing for the admission controller. The difference between the operator is the actual application managing the database, and the admission controller is just an application that validates your YAML file before it gets inserted inside Kubernetes. So as you can see here, we have CB example 0.0.0.0.0.0, 1 and 2. That's exactly what we specified here. We said, okay, I'm deploying Couchbase here, and I want first, in the first section, I'm saying, hey, the password for my database will be administrator, the username administrator, and the password. Here I'm saying, hey, I want you to create a bucket called Couchbase sample. So a bucket is something similar to a schema in a database. And we also are specifying here that, okay, I want 2 replicas of the data, which means that each document will be replicated 2 times. So I can lose like 2 nodes at once, and I still haven't lost any data in my database. And of course, you can say, okay, I want 3 replicas. 3 replicas is the ideal number. I'm just, I have configured here too, just to make things run faster. And of course, here I'm specifying, hey, I want you to use Couchbase 6.6, and then I can configure whatever I want, like how much memory, how many nodes I want, and which services I want to run, of course. Couchbase is a little bit modular, so that's why we have those services here. You can choose which service you want to run, but I can come back to this later. So as you can see, our 2 nodes are already live here. And what I want to do is, of course, the database is empty. So I will deploy a single application to insert data inside Kubernetes. There's nothing special on this app. It will just insert data every few seconds. And here I'm using a simple Spring Data app, because Couchbase also has a SDK for Spring Data. If you're a Java developer, probably you know what I'm talking about. So I'm come here to go back to Lens, and then I come here and say create resource. I paste the whole thing. So here's my whole YAML file, and I hit create and close. And hopefully, if you come to deployment, you see, okay, I have my Spring Boot deployment here. And on pods, you see my Spring Boot application is also here. So what I'm going to do now is just for the port from CB example 0.0.0.0 to my machine. So I just run control and port forward. And now, hopefully, I can come here and access localhost 8091. This is the Couchbase web console. So when you install Couchbase, That's how essentially you manage your database. So you get this for free when you install Couchbase. And as you can see here, we have servers. We have the three servers that we added. And on buckets, if you go in statistics here, you see, okay, yeah, we are inserting data in the database array. Here is where things start getting interesting. So let's add a new bucket here. So I'll call add bucket. And then let's give a name test, right? And I hit add bucket, and here it will appear here, and suddenly it disappeared. Why? Why when I just created a new bucket, it just disappeared? Remember, the YAML file here is a single source of truth. And this is the configuration that should be in the database. So in my configuration, I only specified one bucket called Couchbase simple. When I try to create a second bucket, the operator tries to match the configuration that I have in the YAML file with the database and say, hey, no, this is not valid because you are adding an extra bucket here, but in the YAML file, I only have specified Couchbase simple. So it reversed the change. And I can even try again. So I can come here and add a new bucket here. Yeah, let's just try here. And you see that, yeah, everything gets reverted. And the same is valid for everything else in the database. So when you, the cool thing is when you are seeing the YAML file, that's the correct state that your database is in. Cool. So now let's do something crazy here. First of all, I'm using ephemeral storage here. I could use local persistent storage or remote persistent storage, but in this case, I'm using ephemeral because what I want to do is to come here, see in the third node, and just delete the node. I just kill the node, the pod, right? So I just removed pod CB example 0002, right? And now Couchbase already noticed and say, wait, there is a problem here. So this node became unresponsive. So what's going to happen now is, okay, Kubernetes will notice that we have specified that we want 3 nodes, but now we only have 2. So it will start a third one. And what will happen in a few seconds is, okay, once the node is live, the operator will listen to the event saying, hey, there is a new Couchbase node in this cluster. And it will, as you can see, we have CB example 003 here. And so the operator will call all the endpoints inside Kubernetes to join this node to the cluster, which is why this node is now green here. So we just recovered. But remember, this node is empty now. So the operator automatically triggers rebalancing to move some of the data from the other nodes to the new one, to distribute the load of the database. I don't want to get too technical here, but Couchbase already shards the data automatically under the hood, and this is totally transparent for the developer, and that's why this recovery process is something super fast in Couchbase. So as you can see, okay, we just lost one of the nodes. We completely lost all the data that was in this node, but because we have specified, hey, I have replicas of the data, I can when I add a new node and I recover the state, I can copy the data from those 2 nodes back to the third one, and evenly distribute the data between those nodes to guarantee that, oh yeah, I don't have one node that is receiving more requests than the other nodes. And as you can see, all those things here happen without any human interaction. And that's why you have something similar to a database as a service in your cluster. And of course, there's a bunch of other stuff that I could do. So if you come here, so we have custom resource, and then you can come here to Couchbase cluster, right? On Couchbase cluster here, I could hit edit, and here's the whole configuration of my cluster, right? What really matters to me here is, okay, let's say I want, instead of 3 nodes, I want 4 nodes now. So let's scale out our database. I can hit save and close, and then in a few seconds, a 4th node will appear here, and everything will be handled automatic. So we will join the node to the cluster, we will rebalance data, and I don't need to take any actions at all. As you can see, the node is already live, and we are rebalancing data now. Of course, in a real scenario, it would take more than just 1 or 2 minutes to copy the data. There is one thing that the process of rebalancing is a very well thought process. Let's put that way, because one thing that developers don't realize is, let's say you have 3 nodes and then you lost one of the nodes, right? So now you're serving your application with just 2 nodes. So if we copy the data from those 2 nodes to the 3rd one as fast as possible, that will definitely impact your performance. And one of the problems is, okay, you were saving the user before with 3 nodes, and now you're only serving with 2. So the performance of your application is already downgraded. It is already reduced, of course. So if we just add a new node and copy as fast as possible the data, we could impact the performance of application. So we limit how fast the nodes can copy the data to avoid impacting the performance of application. And of course, as soon as we move one bucket, Couchbase is a truly distributed system. So we notify other the SDKs to say, hey, yes, now this new node is responsible for this document. So whenever you need to request this document, you can go directly to this new node. So cool. There's a bunch of other possibilities here. So because Couchbase is modular, let's say I don't care about analytics or eventing. I could just delete them, and okay, now I'm saving resource because I'm not using those services anymore. Or let's say my application reads more than write, right? So which is I would say, the case for the more short of applications. So what I could do here is I could do something like, okay, for data, as my application reads more than writes, I could have 3 nodes running data, and I don't know, 10 nodes running index, query, and search. Or I could then I could separate those nodes as much as I want. I could specify, okay, I want 10 index, 2 query, and 3 search, for instance. But the cool thing here is that I can adjust the hardware according to the service I'm running. So for instance, data needs more disk, of course, a good disk, of course. Index needs, in general, very good, a lot of memory. And query needs more CPU. So I can adjust the hardware that this pod is running according to the service. And then I can specify, I can scale my cluster according to the characteristic that I want to fine tune. So let's say if it was the opposite, let's say my application writes much more data than reads, I could have something like, okay, now I want 10 nodes running data and only 2 running index, query, and search. And all I have to do is to apply the same configuration here to the YAML file, to the Kubernetes cluster, and the operator knows exactly how to go from this state to this state. And of course, we have now Couchbase 7.0 is in beta. So once it is a GA, if I want to upgrade from 6.6 to 7, all I had to do here is to come here and say, hey, Couchbase 7.0, and then apply this YAML file. It knows how to deploy to upgrade from one version to another. And one thing that I actually forgot to mention is we were doing all this stuff while the application was still live. So as you can see, the application was live all the time here. So that's one of the advantages of those more modern databases, because they were already designed when cloud was already a thing. So the whole design, the whole architecture of the database was already designed around to the fact that, okay, we should be available all the time. And then even if a node fails, we still can easily figure out how to forward this request to some other node to keep the application live. And everything that we did here, the application was still live. Cool. So, of course, the features here are limitless. So some of the other, I don't want to take too much time just explaining all the features, but in our case, whenever you deploy Couchbase on Kubernetes, you can configure automated backups. We also have cross data center replications, which is, okay, I have a cluster here in Europe and a cluster in US. And when I deploy those two clusters, I can automatically configure synchronization between them. I can support metrics, primitives, and well, there is a huge list of other things that the operator can automate for you. And this list is still growing because, yeah, we keep every new version, we add more features to the operator. So of course, there is a natural discussion on should I use DBaaS or database on Kubernetes? I would say that right now, DBaaS in general is easy. Or easier in this case. You have a low total cost of ownership for small and medium workloads because, yeah, quite often you can just keep on the free tier of some cloud providers. So that will reduce your cost, of course. But on the flip side, it kind of lacks flexibility because, yeah, you have to use what the cloud provider offers you. In some cases, oh yeah, I need to cache the database. No, you don't have this option there, or you don't have an option to fine tune your database according to something that you want to boost. And because of that, you just get the average performance that you would get with the database. So quite often they limit on, oh yeah, let's just increase the number of reads, increase the number of writes. But I would say that for databases, it's not that simple in some cases. While database on Kubernetes, on the flip side, it still requires some knowledge of Kubernetes. It is as flexible as bare metal in general, because it is under your control, of course. I would say that operators can automate 80% of the work you have to do nowadays. Is usually a very good choice when you have a large volume of data or a large number of nodes, because then the DBaaS becomes quite expensive. And I do believe that it will be the default option in the near future, because I would say given all this automation that you get when you're running on Kubernetes, it kind of doesn't worth that much to spend your time installing it on bare metal and managing it yourself. So I would say that the future would always be, okay, should I run my database on DBaaS or should I run my database with Kubernetes and operators? And in case, one of the common questions that I receive is this production ready? And well, that's exactly how, guess how Couchbase Cloud works under the hood. So it is essentially a very similar operator under the hood. And I can guarantee you that other cloud providers essentially do the same. Like they have their operators under the hood. And then when you go to the DBaaS solution, you're running the database on Kubernetes, but with some layer in front of it. So essentially, pretty much all cloud providers now are using Kubernetes nowadays for their database as a service offering. So yes, this is already something very widespread in the developer community right now. of course, we need to talk about disks in general, storage. So in this case, I used ephemeral. So when the pod dies, I lost the whole data that was in that pod. But if I was using remote persistent storage and local persistent storage, recovering would be much faster. I just really would like to show you the worst case scenario here. Of course, in this case, I would say there is always this common question: should I use remote or local persistent storage? And I would say that, yeah, you should always prefer local persistent storage over remote, because first of all, local persistent storage is already GA, and second, local persistent storage in general is 4 times faster than remote persistent storage. And the reason why is much faster is obviously because local persistent storage, you are accessing the disk and the machine, while remote persistent storage, you are storing the data of the database in some other in a remote storage, or let's say Rook or something else, right? And of course, then you add up, you have to consider the latency and all the problems that you have to, and all this extra abstraction that you have on the top of the storage. That's why it is slower. Of course, the decision between remote and local persistent storage depends a little bit of the database. In our case, for instance, for Couchbase, we always recommend users to use local persistent storage because the database already replicated data internally, and that's that's something that's why you can use local persistent storage, because you don't need to replicate the data in the disk because the database automatically does that for you. Last thing is, one common question, of course, is, okay, what is the performance difference between bare metal and running database on containers? So 1.5 years ago, we ran this Yahoo cloud serving benchmark, which is a standard benchmark a standard data set to benchmark databases. And what we noticed there was that, okay, for some, there's different inside YCSP, there are different types of workloads. And for some workloads, we saw no difference at all. So for workload A here, we saw no differences. And for workload E, we saw up to 10% performance decrease. So running database on containers are a little bit slower. But worth to highlight that this is, we did this test roughly 1.5 years ago. So, and since then, there is some, we reported some bugs to Docker, and they fixed those bugs and improved, it made some performance improvements. But still, it is safe to say that when you run your database on Kubernetes, you should get up to something around 3 to 4% performance decrease. So make sure to add some extra memory or CPU when you're deploying your database inside containers. So those are the tests. I can share with you guys later the slides. So key takeaways here. Yeah, always consider if I should run my database as a service or database on Kubernetes. If you are deploying your database on Kubernetes, make sure that you use a very good operator. Make sure to add a little bit extra memory or CPU if you're running containers, or in some cases, 2 to 3% is something like, okay, I can ignore that. And that's all right to do that as well. And always choose local over remote persistent storage. Cool. So last slide. Operators are something very popular on Kubernetes right now. There is this operator hub.io, which is managed by Red Hat. And there is a bunch of other operators for whatever applications you can think of. So I definitely recommend you guys to check it out and see if there is some operator that might be helpful for you. So that's what I had. And yeah, thank you very much. I hope you guys enjoy. If you have any questions, feel free to ask.
So thank you, Dennis. And indeed, we already have a couple of good questions. I just shoot you with these.
Okay, let me see.
So the first question is also some kind of compliment. So I just state this. Hey, this is cool. It seems automatic. What about the outage period when something breaks?
Something what breaks?
Yeah, that's a good point, because that is not stated here. I would say just talk a little bit of what you actually did. Yeah, you shut down a pod on purpose, but it can for sure be done randomly. So what happens then? So is the business application safe in those times?
Yeah, I mean, in this case here, we have copies of the data. So even if you have, let's say, even if the whole Kubernetes cluster goes down, because you're using local persistent storage, when you bring this cluster back, you have the operator will kick in and bring your application, your database back to a healthy state again. If you lose just a few nodes, that's again something not a big deal, because the database is already, the database has one job, which is, I mean, two jobs. One is getting your data and writing data and reading data as fast as possible, and the second job is not losing your data, right? And that's why we have copies of the data internally to handle possible failures. So the database already have something internally to notice when a node is unresponsive, and let's say even if it is some network issue, for instance, it will wait a few seconds to make sure that, oh yeah, we really lost this node, and let's try to spin up a new node to bring this back. To recover the previous state. So in general, I would say there is many more scenarios that are covered here that we could even think of, because this is so Couchbase is a very highly scalable, is a very scalable database, and many clients have been. We have many clients running with like 100 clusters with more than 100 nodes, and when you have this amount of nodes running, you do need some kind of automation. And that's why we started this a while ago, before even controllers and operators were a thing. So we started this when Kubernetes were pretty new, because we would like to automate the database management for our clients. And yeah, and I think we have been successful with that. So it's pretty much one of the best experience you can get with database and operators on Kubernetes.
Because we have a couple of more questions, and just let's say 6-7 minutes to go, I would give you the next one. Can my application reach the database cluster all the time during an upgrade?
Yes. So you can, while the upgrade, because the way the upgrade works is, okay, I remove a node, and it is usually compatible, right? The previous version with the current one. So you can just remove a node and add a new, remove a node version and add a new version, and that's how we make upgrades. So everything you do here, your database is fully available. So that's some of the cool stuff with those modern databases.
And next one, am I limited to any platforms?
Nope. You can deploy, we are certified on GKE, on AWS, and all the cloud providers, or you can even run on Minikube on your machine. Of course, you have to do enough memory, because Kubernetes is a little bit, takes some processing power from you. But yeah, you could you can even create your own cluster. And here, for instance, I'm using EKS. Or if you want to run on, let's say, DigitalOcean or whatever, is totally cloud agnostic. So that's totally up to you. And that's one of the cool things here as well.
I think we can state everything you can run Kubernetes on, you can run this Couchbase autonomous operator, and the same is for sure valid for Red Hat OpenShift. Just to summarize this up. So let me see. Here's another one. I have one question about service param. What is the minimum and maximum to configure in the file? Thanks.
So number of servers, of course, the minimum is 1. The recommended is 3, because then you have, we recommend 3 just because of replicas, right? So, okay, if you have like one MySQL database and then you lose the database, you lose the data in it, of course. Because we are distributed database, we recommend a 3, because then you have 2 copies of the data, and even if you lose 2 nodes, you still have your database available and without losing any data at all. But in theory, the limit for Couchbase is 1024, because that's the number of vBuckets that we have under the hood. But so far, the biggest clients that we had, they have a little bit over 100 nodes in a single cluster, which is already like a lot, right? Considering that Couchbase is a strong consistent, right? We're not talking about something like Cassandra, which is event consistent. So event consistent, essentially, you write the data, but when you try to read again, you might get an old version of the data. That's not what Couchbase is. Couchbase is very similar to a relational database to some extent, although we store data as JSON or similar to MongoDB, of course, but you can scale to hundreds of nodes and still be strong consistent. So whatever you write is what you're gonna read.
And this one, I think you covered this up already, but I state it again. What can I control with this operator? And maybe Dennis, if you allow me, I would quickly
of course, yeah, go ahead.
Quickly grab the screen and show the audience this is actually what Dennis just showed you, the operator hub.io here with the Couchbase operator. And with regards to the question coming in, what you can control, I think Dennis and I agree, and it is stated here, blue on light blue, you can control everything with our operator. Yeah, so in the operator, there's a framework. In the operator world, there's a framework with capability levels, starting at the basic installing level over the seamless upgrade level, full life cycles, meaning also including auto recovery, etc. Deep insight level, which is in fact the 4th level, which deals with monitoring aspects, and the most matured level is the autopilot. And you see the boxes ticked 5 times for the Couchbase operator, which we can proudly say it is the most mature operator currently available on the market that automates really everything in your daily work on the ops side. Yeah. So that was with regards to that question. So let me see if I missed something for you, Dennis. Maybe Dennis, you can give the audience one more thought on the differentiation between DBaaS and doing it by myself, because we have the question here, I wonder why I should consider this approach executing by myself, because I can go with a DBaaS solution.
I would say that one thing that I would like to say as well, if we have some time, but I would say the DBaaS in general depends on the cost, of course. So at some point, if you have a lot of data, DBaaS also becomes very expensive. And also performance might be another issue as well, because you don't have at some point, there's some threshold where the best becomes one expensive, and other not gives you enough performance. So depending on the number of clusters, or maybe I would say there's even some other approaches as well. So you could use operators for your deployment for your staging environments, and the best for production. So there is a bunch. The right answer here is usually you can use a mix of both. So for some use cases, you could use, for this small application here, we don't care, let's use the best. Or no, this application is mission critical, we really need to fine tune the database, let's make let's use operators. And of course, it's also a problem of SLA, so how fast your queries should run. So in some cases, for the best, it's hard to make your queries faster than some specific threshold because of how things are deployed in the cloud provider. So it is a very nice question, to be honest. I have to create a talk just about that. But the line here between database on Kubernetes and the best are not yet clear. And that's why, for instance, for Couchbase, we offer both options. So you can use the Couchbase cloud, or you can deploy this on your own cluster.
Great, thank you for this. And last question, just to cover it up, and I give you just 1 minute to answer, please. How is the migration from other systems working?
How to migrate from, relational to Couchbase, or what?
I would use this example because it is not stated here, which exactly.
Yes, so if you need to copy data, there is, for instance, job. You can use a job on Kubernetes to copy data from one database to Couchbase. And of course, like, let's say if you're using relational, then I would say there is you can migrate in 2 steps. One is copy your data from relation to Couchbase, and the second one will be remodeling to store data as JSON. So we have a very good material out there saying how do I migrate from relational to Couchbase, for instance.
Mm-hmm. Okay, great. So thank you very much, Dennis. This was the Couchbase session with Dennis Rosa, and I just want to highlight the chance again, clicking on the banner on the bottom of the live stream to have the possibility to win 200 euro Amazon vouchers. 3 of them are in place to win. And we wrap this up here. Thank you again, Dennis, and for all of you guys staying with us. We will now come to the session from our friends coming from Confluent with how to benchmark your Apache Kafka. So I see you there. So, hello everybody. Welcome back to our next session, how to benchmark your Apache Kafka. I welcome you, Kirill Kulukov, a consulting engineer from Confluent. And I'm personally excited to hear more about this topic because Kafka is very, very powerful system, but also can become complex. And therefore or it is good when you know how to properly benchmark it from different angles. And I'm happy that we can listen to you now, Kirill. So the stage is yours. And for the total audience, I highly recommend making this session also very interactive by putting in your questions on the WeAreDevelopers homepage on the right-hand side. Near to the live stream, there you can find a question window where you can place your questions, and also at the bottom you have the possibility to win by clicking on the Couchbase banner a €200 voucher for Amazon. So the stage is yours, Kirill.
Thank you for the introduction. Hello, so my name is Kirill Kulikov. I'm a consultant engineer with Confluent, the company founded by the original creators of Apache Kafka. And I'm delighted to be here speaking at WeAreDevelopers. So I work at a professional services team, and our day-to-day job is to help customers succeed with Apache Kafka. Apache Kafka is a complex system with multiple parameters to configure for different use cases. And as a consultant engineer in Confluent, I can see many clients who need to benchmark their production systems and understand their capacity. So benchmarking and measuring are not just for finding a bottleneck. You need them to better understand the loads you're placing on the system. And benchmark details can be used to optimize throughput, latency, and better utilize resources. This talk will focus on methods and tools of Apache Kafka performance analysis and benchmarking. And today I'm going to briefly review Apache Kafka architecture, so we are all on the same page. Discuss latency and throughput goals and how we can achieve them with Kafka. And then examine benchmarking techniques and popular tools. So Apache Kafka fundamentals. Well, at the very heart of Apache Kafka is events. They can be human-generated, like online orders or clicks, or machine-generated, coming from IoT devices or applications. Each event basically is a key value pair, though you can have events without a key. The log is the most crucial building block of Apache Kafka. And when I say log, I don't mean application log like log4j in Java. Here, the log is when we take our events and append them to the end of the file over time, which guarantees that events will never change. The log is immutable and append only. And Kafka organizes data into topics. And topic is a concept that provides facilities to work with an immutable, append only, and distributed log. But topic is a logical concept. Topics are organized into partitions to make the log distributed and scalable. And messages are guaranteed to be strictly ordered within a partition within a topic. To make your data durable, you can have as many replicas as you want, but typically 3 or 4. One of those replicas is assigned as a leader and others are followers. And if the leader fails, one of its replicas is promoted. This is basically how we get our durability and availability in Apache Kafka. So how do you get events into the distributed commit log? to get data into a topic in Kafka, we use a producer. The producer writes data to the end of the log, and the producer decides which partition are we going to write. So producers are always writing to the leader, and messages without a key are produced in round-robin fashion. But messages produced with a key will be assigned to particular partitions. And messages for a given key will always end up on the same partition. Sorry. So to get data out of the topic, we are going to use consumer API. And when we consume data from a topic, we do it in sequential order. So consumers regularly commit offsets to track their progress. And there can be multiple consumers, and Kafka will track how far each consumer has got. If you have a single instance of a consumer, it will read data from every partition. But we can scale consumers horizontally when we assemble into consumer groups. And so each of those consumers will get data from one or more partitions. And Kafka keeps track of how many consumers you have in a consumer group and rebalance them if you add or remove one of the consumers. So all systems are different, and to tune your Apache Kafka, you need to understand your workloads. How does one get the most throughput and lowest latency from Apache Kafka cluster? Or how much throughput you can get from a single partition? Understanding your systems helps in benchmarking and tuning Apache Kafka, as you can shape data and workloads to your actual requirements. Then it would help if you decided which service goals you want to optimize. So here in this talk, I will consider two goals that often involve trade-offs with one another, throughput and latency. And to figure out which goals you want to optimize, recall the use cases your cluster is going to serve. There are Kafka configuration parameters that you should change to optimize for those service goals. You need to understand what your users expect from the system and to ensure you're optimizing Kafka to meet their needs. So do you want to optimize for high throughput, which is the rate the data moved from producers to brokers or brokers to consumers? Because some use cases can have like millions of writes or reads per second. Or do you want to optimize for low latency, which is the elapsed time moving messages end to end from producers to brokers to consumers? There are hundreds of different configuration parameters in Apache Kafka, and we are going to discuss just a small subset of them. Remember, benchmarking is always important to validate the settings for your specific deployment. So end-to-end latency. When we talk about latency, we talk about end-to-end latency usually. But what does that mean? Well, benchmarking Apache Kafka, we should measure times between measure send using producer.send method until consumer.poll returns that record. But in order to optimize Apache Kafka and to measure the latency, we need to understand what happens in between. So produce time is time spent processing the record and batching it with other events in Kafka producer. Then publish time, which is sending the record from Kafka producer to broker and appending it to the leader log. Commit time is replicating the record to follow replicas for fault tolerance, which is basically the time of the slowest replica to catch up. Then catch up time, catching up to the record's offset in the log. And fetch time is actually fetching the record from the broker. So optimizing for latency. Each Kafka topic contains one or more partitions. And when Kafka producer sends a record to a topic, it needs to decide which partition to send it. If we send several records to the same partition at around the same time, they can be sent as a batch. And processing each batch requires some overhead, with each of the records inside the batch contributing to that cost. Batch is completed either when it reaches a specific size, it is a batch size configuration parameter, or after some time, it is a linger MS configuration parameter. By default, the producer is tuned for low latency, and the configuration parameter linger MS is set to 0, which basically means the producer will send as soon as it has data to send. Also, consider whether you need to enable compression. So enabling compression typically requires more CPU cycles to do the compression, but it reduces network bandwidth utilization. The record is acknowledged based on X configuration, which controls the durability of records. There are three options basically. X equals 0, which is like reply immediately without waiting for a reply from a broker. And then X equal 1, acknowledge the message after appending the message to the leader, and X equal all, to acknowledge the message only when all followers and the leader acknowledge the message. It is a common belief that to minimize latency, you need to set X equal 1, which guarantees writing to the leader log. It is true if you are interested in producer latency only, but wrong if we consider end-to-end latency, because consumers can't consume a message until it is written to the followers. In Kafka, there are automatic checks in place to make sure consumers cannot read messages that haven't been committed yet. So basically, setting X to 1, you are sacrificing data durability for nothing. Also, you can tune consumers for lower latency by adjusting how much data it gets from each fetch. By default, the consumer configuration parameter fetch min bytes is set to 1. And it means that fetch requests are answered as soon as a single byte of data is available, or the fetch request times out waiting for data to arrive. There is a fetch max wait ms configuration parameter to control that. Partitioning strategy determines how batches work. If records are not sent to the same partition, they cannot form a batch together. And the default behavior is to hash the key of a record to get the partition number. And but some records may have a null key. In this case, the old partitioning strategy before Apache Kafka 2.4 would be to cycle through the topics partition and send a record to each one. So unfortunately, this method does not batch very well, and may in fact add latency. So this ticket partition addresses the problem of spreading out records without keys into smaller batches by picking a single partition to send all non-keyed records. And once the batch at that partition is filled or otherwise completed, the sticky partition randomly chooses and sticks to a new partition. That way, over an extended period, records are about evenly distributed among all the partitions, while getting the added benefit of larger batch sizes. And when comparing the 99th percentile latency of a cluster with 3 producers that produced 1,000 messages per second to topics with 16 partitions, the sticky partitioning strategy had around half the latency of the default strategy. And you can see test results on the diagrams on the slide. And the decrease in latency became even more visible as partitions increased, which is actually in line with the idea that a few larger batches result in lower latency than many small batches. So yeah, that's the slide. So optimizing for throughput. So we discussed how to optimize for latency, and now we're going to discuss optimizing for throughput. And to optimize for throughput, the producers, brokers, and consumers need to move as much data as they can within a given amount of time. And for high throughput, you are trying to maximize the rate at which data moves. And topic partition is a unit of parallelism in Kafka, and messages to different partitions can be sent in parallel by producers, written in parallel by brokers, and read in parallel by consumers. So in general, a higher number of topic partitions results in higher throughput. And to maximize throughput, you want enough partitions to utilize all brokers in the cluster. But there are trade-offs to increasing the number of partitions, like a higher request rate or for lower fetching, which results in higher broker CPU usage. So moreover, poor batching might happen when producers send requests to a very large number of partitions. So yeah, remember to choose the partition count carefully based on producer throughput and consumer throughput, and benchmark performance in your environment. Also, take into consideration the design of your data patterns and key assignments so that messages are distributed as evenly as possible across the topic partitions. Because it will prevent certain topic partitions from getting overloaded relative to other topic partitions. And yeah, so yeah, you need to monitor your data and make sure that it's not skewed. The most important step you can take to optimize throughput is to tune the producer batching to increase the batch size and the time spent waiting for the batch to fill up with messages. You can configure the batch size configuration parameter to increase the maximum size in bytes of each message batch. And to give more time for batches to fill, you can configure the linger ms parameter to have the producer wait longer before sending. The delay allows the producer to wait for the batch to reach the configured batch size. But there is a trade-off, which is tolerating higher latency, since messages are not sent as soon as they are ready to be sent. Also, you can easily enable compression, which means a lot of bits can be sent as fewer bits, basically. And yeah, you can enable compression by configuring the compression type and configuration parameter. And there are 4 standard compression codecs: LZ4, Snappy, ZSTD, and JZip. And for performance, we generally recommend avoiding JZip because it can be CPU intensive. And compression is applied on full batches of data, so the efficiency of batching will also impact the compression ratio. Important thing is you need to make sure that compression codecs are matching for producers and topics. Otherwise, the broker will recompress data to match the codec of the destination topic, which can result in a performance impact. And when a producer sends a message to a Kafka cluster, the message is sent to the leader broker for the target partition. And then the producer awaits a response from the leader broker to know that its message has been committed before proceeding to send next events. And the sooner producer receives a response, the sooner the producer can send the next message, which generally results in a higher throughput. And so setting X to 1 makes the leader broker write the record to its local log only and then acknowledge the request without awaiting acknowledgement from all followers. But there are trade-offs again. The trade-off is you have to tolerate lower durability because the producer does not have to wait until the message is replicated to other brokers. Likewise, you can tune the consumers for higher throughput by adjusting how much data it gets from each fetch from the leader broker. And you can increase how much data the consumers get from the leader for each fetch request by increasing the configuration parameter fetch min bytes. And this parameter basically sets the minimum number of bytes expected for a fetch response from a consumer. And increasing this will also reduce the number of fetch requests made to the broker, reducing the broker CPU overhead to process each fetch request, and thereby also improving throughput. So load testing. How do you evaluate performance for all different use cases? Well, you need to measure. And whenever you want to change any configuration parameter, you need to run performance tests to understand how it affects your system. For example, you want to enable the events compression. You need to run multiple benchmarking tests to understand if it's the right decision for you. Load testing your system has 3 main objectives. They are assess the system's breaking points, assess the system's maximum capacity, and verify the system's ability to recover afterwards. And you can test these measures in 3 different ways, which are stress testing, or where you put your system under heavy load just beyond average operational capacity, often to breaking point, and you observe the results. And then spike testing is a type of performance testing in which a system receives a sudden and extreme increase in load. And the goal of spike testing is to determine the behavior of a system when it receives extreme variations in traffic. And finally, soak testing checks the endurance of your system. It involves testing a system with a typical production load over a continuous availability period to validate system behavior under production use. And when you run your performance tests, you need to pay attention to system setup. So make sure you do not run performance tests from the same machine as you host your Kafka broker or any other Kafka component. Also make sure that there is enough network capacity between your test cluster and your Kafka cluster. Check if it has enough CPU and memory to run your performance tests. Pay attention to the system setup, like swap configuration, network, I/O, JVM settings. Yes, each system needs time to get up to speed. And for every Java application, JIT compiler needs to run to bring it into a steady and performant state. And Kafka is a Java application. And you do not want to benchmark a new Kafka cluster from its first second. So it needs some time to warm up. And the Java-based benchmarking tool needs to warm up as well. Sometimes you can observe a latency spike at the very beginning, which drops a few seconds or milliseconds later. And when you run performance tests, there is always some run-to-run variance. Sometimes your tests are a bit faster, sometimes they're a bit slower. And you should run your tests multiple times to understand your actual baseline and for comparison. Usually one test run is not enough. And when you run your test, the latency variance should be normally distributed. When you look at your test results, make sure you don't look at the mean, as the mean is meaningless. It just means that half of the requests were worse than the mean. And the better solution is to look at percentiles. A percentile is basically a value below which a certain percentage of observation lie. So it is quite common to use 95% or 99th percentiles. If your latency is in 99th percentile, it means that only 1% of requests took the same or longer time. Also, make sure that your load is even, because your workload might be skewed when a single partition gets more throughput than other partitions. Also, if you have a chance to use real data, it's usually good. So test with real data whenever possible. So you need to know the capacity of your system, its limits, and how much headroom you have. And for that, you need to know your use cases. So like how much traffic do you expect? What is your spike load? What is your consistent load? But then with monitoring, with observability, you can run load testing to see the limits. So the monitoring and observability of your Kafka cluster is very, very important, as monitoring helps provide assurances that all your services are working correctly. And it would help if you had observability in your system. Without monitoring, you're basically driving blind. And out of the box, Kafka exposes its metrics via JMX. And any monitoring tool with JMX support should be able to monitor Apache Kafka cluster. And yeah, so as I mentioned, it is essential to collect JMX metrics from Kafka brokers. And beside the broker metrics, it is also very, very important to measure the consumer and producer, which expose JMX metrics as well. Moreover, it would help if you collect system metrics. Make sure that you track things like memory usage, JVM heap size, and things like swap usage, network. Keep an eye on dropped packets. disk I/O, disk usage. Make sure you always have enough free disk space for new data. Your disk space threshold should be around 70 or even 60% of the disk space. And here on these slides, there are two examples of popular dashboard tools. One of them is Grafana on the left and Content Control Center on the right. So, there are specialized tools to test Kafka's performance, but out of the box, any Kafka installation comes with command line tools designed to do just that. And these command line tools are Kafka Producer Performance Test and Kafka Consumer Performance Test. And you can run performance test scripts with different configuration settings. And here are two examples of one of them is for Kafka Producer Performance Test, and another one is for Kafka Consumer Performance Test. And in the following example, we will produce 5,000 messages with a size of 2 kilobytes each. And the above command example will create randomly generated byte records of the specified size. And the -1 value for throughput means that messages are produced as quickly as possible with no throttling limit. Another option for producing test data is to read it from a file randomly. So in this example, 333 messages are produced per second on average, with an average latency of approximately 7,500 milliseconds and maximum latency of 14,500 milliseconds. And the 99th percentile latency of 13,400 milliseconds means that for 95% of messages, it took less than 13,400 milliseconds between when they were produced and when they were written on all brokers. In the same way, the 14,500 milliseconds value for the 99.9 percentile means that 1 in 1,000 messages experienced a delay of more than 14,000 milliseconds from when it was produced until it was published and committed on all brokers. Also, there is a print metrics parameter which prints out the producer JMX metrics at the end, which is very useful if you want to grab your producer or consumer JMX metrics and to look at them after you run the test. Kafka Trogdor. Yeah, so Apache Kafka has built-in test framework named Trogdor that can be used to perform fault injection or to execute workloads for a test system. It is open source and part of your Kafka installation as well. And Trogdor can run benchmarks and other workloads. And also, Trogdor can inject faults in your system to stress test it. So Trogdor has a single coordinator process which manages multiple agent processes and tasks. And the task is anything we might want to do on a cluster, such as running a benchmark or injecting a fault or running a workload. This task specification is usually written as JSON, and example of this JSON configuration can be seen on the slide. And the source repository of Apache Kafka includes an extensive test suite for system integration and performance tests. And there is a link on the slide. Another popular tool which alternatively can be used for specialized performance testing is Apache JMeter and Pepperbox plugin for Kafka load generation. To load test your Kafka installation. So Apache JMeter is a Java desktop application designed to load test and measure performance. And it was initially designed for testing web applications, but has since expanded to other test functions. And this way, using Apache JMeter and Pepperbox, you will be able to conduct the load having full, to conduct tests where you can have full control of threads, ramp up time, message size, content, and so on. And also you will be able to generate HTML dashboard, having tables and charts with all the useful metrics. So performance and performance measurement are multidimensional, and they depend on multiple parameters, settings, and conditions. You need to understand the system and to be able to explain the results. And it would help if you approach performance measurements mindfully. Thank you.
Thank you, Kirill. So for sure, there are or is also some question and answer round here.
Okay.
And I will start with one I see directly. Would I already use Trogdor when building my system, or in the end when it is built?
Well, I think both ways are valid. So you can, as long as you build the system, you can use Trogdor, and you can benchmark your system and maybe adjust your configuration settings according to results. But if you have your Kafka cluster and you've never load tested it, maybe it's a good time to do that. And you can certainly do that with Apache Trogdor.
Okay. So actually, if you allow, I personally also have a question I would like to ask you, because I consider this topic very important because of its complexity in there. What are, let's say, your personal 2 or 3 silver bullets where you would say, okay, these are the angles you need to care about and to keep in your eyes monitoring Apache Kafka and its potential data growth?
Okay. So yeah, well, when you monitor Apache Kafka, what's most important? Well, one of the metrics, for example, is a consumer lag. So you want to make sure that your consumers can keep up with the load. Yeah, as I mentioned before in the talk, system metrics are very important. So like things like disk space, especially if you run on premises, because it's easier to add disks in the cloud, but sometimes it can take days or weeks if you run on premises. And yeah, so it's better to monitor the disk space and to act in advance. Yeah.
Okay. Good. One ask from my side. Technically, can you end your screen sharing so then we can act a little bit more interactive? That would be fine.
Yeah.
Perfect. Okay. Thank you. Yeah, well, so the reason why I raised the question is because not only valid for Kafka, but for, I think, all distributed systems for the modern world, it is highly important to have a proper monitoring, even more than in the monolithical system world, because it can extensively grow, right? So
Yes.
if you want to build an event stream with Kafka and you want to establish such a streaming architecture approach in enterprise environment, for example, it can easily get very extensive in a very short period of time if you do it accurately. And what I've seen in the field oftentimes is that even when it's basic, it is not properly considered the monitoring aspect. Yeah, so the enterprise starts with this new kind of technology approach, distributed fashion, and miss the fact. Okay, well, they are blind actually. And so I was interested in how you would recommend to let's say solve this a little bit, yeah, by thinking proactively what metrics are very useful, not in the tiny details, but for sure from a bird perspective. And yeah, happy.
Yeah. Other metrics which I can think about is are like things like under-replicated partitions. So you want to make sure that you don't have any under-replicated partitions. Yeah, and obviously number of your active brokers. You want to make sure that all your brokers are alive and healthy.
Can you maybe this is also interesting to the audience, even when it's not tightly coupled to monitoring itself, in terms of the many connectors the tech company established towards Kafka. So also we did from Couchbase, we established a bidirectional connector to act not only as a producer, but also as a subscriber. Can the corporation using Kafka as the central flow, let's say it this way, throttle the connection a little bit coming in from other systems proactively? Or is the Kafka and the connection cluster purely a taker without any control of how much is taken in some certain point in time from a data throughput perspective? Because you also can monitor this. So the question is the natural next one, can you throttle it from the Kafka side?
Yeah. Well, there is a concept of quotas in Kafka. So using quotas, yeah, you can throttle
okay.
Data. Yeah, which is actually important if you have like a multi-tenant cluster, because then you can have like different parties competing for resources. And so, yeah, using quotas can be very important.
Okay, great. Good. So I see no further questions arrived so far.
Okay.
So then I would say if you have some final thoughts on the topic, you feel free to share it. Otherwise, I highly thank you for presenting here this topic. I considered it very useful. And yeah, it was great having you here with us.
Yeah, thank you very much. Yeah, it's a pleasure speaking at WeAreDevelopers. And yeah, I'm going to enjoy a few talks later this week.
Great. Perfect. So for all the audience out there, again, the hint, you can win a €200 Amazon voucher by just clicking at the Couchbase banner under the live stream at the WeAreDevelopers homepage. And yeah, feel free to do it. And stay with us for the next upcoming session from software, from a software consultant, Derek Binkley at Spark Labs, that will introduce us to how you can add location-based searching to a site using Elasticsearch. I'm glad to see you there in a couple of minutes.
Thank you.
When magnetic fields move and electrons start flowing. When you feel that anything is possible. When the night can turn into day. Then a new modern world is possible. Electricity gives impulse to our imagination. Passion and precision are at the heart of our work. Anytime.
VKW. Energie für Generationen.
So here we are again. Hello, everybody, to our next session presented by Derek Binkley from Spark Labs. And here it is all about geospatial together with tagging in the session at location-based searching to your site with Elasticsearch. I'm glad to have you here. And just for the audience out there, again, you find at the right-hand side a window where you can put your questions in, and you also find at the bottom the Couchbase banner where you can add your contact details to win a 200 euro Amazon voucher. So, Derek, the stage is yours. Feel free and enjoy.
Okay, thank you. Thanks for the great introduction. And today I'm here to talk about location-based searching, adding it to your site. And we're going to be talking about, or we're going to be using a product called Elasticsearch to do that. So before I get into the geo parts of it, I want to give you a little bit of background about the tools that we're using. So first of all, we need to talk about what is Elasticsearch. In case you're not familiar with it, it is based on the Apache Lucene project. So it's basically a number of text indexes that have been made extremely efficient for running lots of different types of searches, including geo searches and text searches. One really nice thing about this Elasticsearch product is that it operates based on REST calls, which means that you don't have to learn anything new to interact with it. There's no proprietary protocols or new language to learn. You just need to know what type of payloads to send to it. And that's what I will be talking about today. There are SDKs in many languages like Node and PHP and Java, JavaScript. However, because it's REST-based, you don't necessarily need an SDK to get going, just because the format of the payloads of the data that you're sending to it is relatively standard. So you know, those are available, but they're not at all required to get going. And this is an important thing to keep in mind with Elasticsearch. It is read optimized. And what I mean by that is that it is meant to return data to you quickly. It's not set up to be a transactional database. And in fact, a lot of applications with Elasticsearch just use Elasticsearch for part of the data. They don't use it as their entire data store. And I think that as you're interacting with it, it's important to realize just what the important pieces of Elasticsearch are, in that it's meant for search. The Elasticsearch product has 4 main components. They call that BELK, a Belk stack. We're going to see 2 of those in action today. First is called Beats, and that's how you can get data streams into it. A really popular way of using Elasticsearch is bringing in log data, and Beats can do that. It can do lots of other things. Honestly, I don't really work with it very much, so I don't know the ins and outs of all of it does, but you'll see references to that once you start looking into Elasticsearch. The main product is just Elasticsearch, which is, their tagline is, for search. That's the main engine that runs the indexes. There's also this thing called Logstash. It's just more dashboards for visualizing your logs. We're going to talk about that today. One thing you are going to see today is the Kibana, which is their browser-based client. It's really helpful because it allows you to have syntax highlighting and prompting for creating the REST calls. So when you're testing stuff out, it's really helpful to use that. It has a lot more than that, but today we're just going to see how we can use it for crafting our gets and our posts and our put requests to that Elasticsearch stack. Elasticsearch is available lots of different places. AWS has pre-built images, so you can just launch Elasticsearch directly there. Another really cool thing that I came across recently is that if you're using any sort of GraphQL schemas like AWS Amplify or their API gateway or any other way that you're getting GraphQL data, you can add a @searchable annotation to that to your schema, and it'll automatically persist your text fields in Elasticsearch for you, which is really cool. Because then you can build GraphQL resolvers using those get and post commands that you'll see today. So that's just another way to tie in GraphQL with that if you're so inclined. You can also get it hosted by Elasticsearch, or you can, or the Elastic Co, I guess, is the company that makes money off of this. There's also, you can install it on any image. Today, I'm actually going to be running it on Docker. I have a Docker container that uses Elasticsearch and Kibana. So what are we going to build today? Basically, I want to build an API that can serve as the backend of a site or an application. I'm just going to show you here. Unfortunately, there's some an error message, but essentially what we want to be doing is building an API. Hopefully this is big enough that you can see it, but that brings in query data. And actually here I will this up. It brings in text data, it brings in a latitude and a longitude, and in this case, optionally a radius, and allows you to search and find out what's in that, what's near this geo point. So that's the goal for today. So we want to search text in there, and we want to do it really fast. We want to search locations that are nearby a specific point. For example, if this were a mobile app or even a website, you get the user's location, you pass that on to your search, and you can tell them, okay, these are things that match your search and they are close to you. We also, I've already added the locations, and if we have time, I'll show you just a quick how to set up the users to comment on the existing locations. And like I said, this is just an API that that we're building together here. Okay, I don't expect you to memorize this Docker Compose file, but I will have the slides available somewhere after this talk, and I'll make sure to put that on Twitter. So feel free to follow me. I will also use the Twitter, the WeAreDevelopers hashtag, just so you can find these slides later, because there's a lot of code like this. But basically, if you just have this file, run Docker Compose, you can get up and running with two things. One, you'll have Elasticsearch running at port 9200, and you'll have Kibana running at 5601. And before we start looking at it, it's really important to know a few terms about how Elasticsearch saves that data. Well, it's all JSON documents, which makes it very compatible with REST APIs and lots of different apps. But it's a little bit different than a standard document database because it is so based on indexing and searching. And Elasticsearch has what they call an index, and this is just a group of documents with a similar structure. Basically, what that means is if you're thinking about a table, well, this is your table definition. Your table is the index, and a document is the row. And then, of course, you have a mapping that tells it, well, what is actually in that. And this is one place where it's a little bit different from a standard document database because of how you can define the data. So here's an example of putting setting up your data for a location mapping. I'm just going to real quick go through some of the data types just so you know what's available. For example, you can have an integer, you can have a text data type, and anything that's marked here as text, you can see I've got three different types of names stored with this location. And that text information is actually what gets put into the index, and that's what you can search on. And then we've got a geopoint, which just stores a latitude and a longitude. It's not the only way to store a location. You can actually store, GeoJSON. You can also store a polygon. So for example, if you wanted to store the shape of Germany or Austria, it would take a lot of points, but you could do that. And then you could search based on, okay, am I in this country or am I in another country? And another important data type here is the keyword. A keyword is like a lookup field. It's going to be different than a text because it's not going to be indexed in that same way. So this is something that's usually a fairly confined, fairly static list that you might want to filter on versus searching. And in a little bit, we're going to learn the differences between filtering and searching because it's really important in the Elasticsearch world. So when I ran this, we get back, some JSON telling us that, yes, it ran, and it gives us the name of the index. That's just one thing I should point out here. When I'm doing this put, I'm specifying the index here. In this example, this location list does not yet exist. And then down here is location is what's considered my document type. So that's the actual document itself inside the location list. Now, another thing that you may want to look into if you really get into Elasticsearch is the fact that it is sharded. The data is sharded. I'm not going to talk too much about that, but I want you to be aware that that is happening behind the scenes. And if you really have lots and lots of data and you are you'll need to look into that and see the best ways to optimize those shards. You can specify on an index how many shards it runs against, and you can distribute that over servers so that you can make your your data store as efficient as possible. Now, we already talked about text and keywords. And geopoint, those are the most important data types for what we're doing today. Like I said, you can also store a geoshape, and there's a lot of your basic other types of data: logs, integers, shorts, booleans, binaries. So you can really store a lot in here, but these top, especially the top three on here, are the ones that are going to be most important for what we're building today. Elasticsearch, I think, has really good documentation. Not all products have great documentation, so I really like to give a shout out to their documentation team. I feel that it's really easy to find what you need there. So I just have a link here to their mapping types. So it explains in detail what you can store. And one thing to note, if you're using the AWS version of it and you're using like GraphQL or something like that, they've actually added some of their own types to make it even more useful for you. So for that, you would have to look at the AWS documentation. So before we get going actually searching, I just wanted to bring up, this is what in the data that I've got is just a list of locations. And I just wanted to show you that this is a example of what they call a feature class. This is just in the data set that I've got. Has nothing to do with Elasticsearch itself. And it has a feature class and a feature code. And I just wanted you to see some examples that these are, kind of stream banks, streams, lakes, lake channels, navigation channels, stuff like that. So this is what I meant by when you want to store something that's fairly fairly constrained in a keyword, because you're not going to be searching the text of this. You're actually going to be looking for the code B and K or the feature class H or something like that. So I'm going to switch over now to show you some live queries here. Now, the first thing that you can see here, this is Elasticsearch itself running on port 9200. And if I didn't specify any sorts of queries, so it just gives me some default JSON, just so that you know that it's running, and some information about it. The nice thing about Elasticsearch is that you can just post your queries directly to 9200, and then they'll run, and you'll get that JSON data back. However, today, like I mentioned, we are going to be using Kibana. This is what that looks like. It's got a really nice, highlighted syntax, and it tells you if something isn't right. I've got some data wrong. I'm seeing a little red X down there, and then okay, now I can run this. And when you're running this, you're just doing, I'm doing a git at my index, my document type, and I'm calling the search endpoint in that. You can actually just like remove those and search, and you'll get just like everything in there. Not quite as useful, but if you want to know what's going on, that can be helpful. So I'm going to run this here, and just take a look at what we got. This is, as you can see here, this is just over 1 million records. And one thing about Elasticsearch is that because it's trying so hard to be fast, it's not going to give you all 1 million records or paginate that for you. It's just going to give you the first 10 matches. Since we didn't give it a query, it's just whatever was easiest for it to bring back. You can see here, it tells us, okay, this is a location list, the type location, and a score. Well, the score is just 1 in here because I didn't give it a search. And this source here is our actual, document. This is what we care about. So you can see here, this is, we've got a name, and we've got our geo point. That's going to be important later as we build this. It also gives us an elevation and what time zone we're in. So let's see here. Oh yeah, one thing that I want to mention before we go on is that this score is going to be important, because that's how Elasticsearch decides what a good match is. And that score is it can't be compared from, what should I say, from query to query. It's just relevant for sorting that particular query. So let's just move on, and I'm just going to actually type in something else here. I just wanted to show you that what we're doing here is we're doing a match on the name. And the reason I chose something new is because I wanted to show you this is something that I haven't ever run before. It's not cached or anything like that. And I want you to take a look at this, this number up here. This is in milliseconds. So it searched that 1 million records in just a little over 100. So this is like 1/10 of a second. That is really, really fast to go through 1 million records and find, let's see, it found 116,000 plus matches and ranked them for us. You can see here, well, obviously one that says new school. That's, the best match. New Hope School, not quite as big of a match, but still good. So I just think that is really amazing that you can get those type of results back quickly. I just wanted to point out too that I'm not running this on some big server. This is all running locally on my laptop, which is, I think, about 4 years old now. So it's not like we are really dealing with something that is, we don't have like, excuse me, we don't have like a huge amount of processing power being dedicated to this. It's a relatively modest Docker container that is running all of this. So now I just want to get back to that difference between a text search and a keyword search. If you can see here, I've changed my query. First, I did a query match, and then I gave it a name. And this is something where you can put in text, and it's going to try as hard as it is to find. Okay, well, there is an exact match for that too. But you can see here, well, I searched for New River School, but New River also comes up. Let's see here. Maybe if I put in something that's a little less fuzzy. Oops, I just deleted all of my queries here. All right, let's get back to that. I just wanted to show you here. Okay, so there's nothing actually called Old River School, but Old River seems like the most relevant match. Old River. So yeah, apparently there's a lot of things called Old River in this database. Okay, but now we've got this this filter. You'll see a lot of the queries here wrapped inside a Boolean, which just allows you to chain together commands. You'll see here you can even put matches inside that, but for right now, I'm just going to show you, okay, this is a filter. A filter is different from a match because I'm still querying it, but something that you filter by is just a yes or no. Does it match it or not exactly? And it doesn't rank it. So you can see here that this is you're getting a max score of 0, and everything here has a score of 0. So this is basically just 10 random records that has our filter class of L. And they're in no particular order because I didn't give it anything else to narrow down that. But this is a good way to search on a particular keyword. If you have, some sort of data source and you're looking for restaurants near you, and you have a class of R for restaurant, then you can, you can say, okay, I've limited that search, and now I can look for other terms inside that. And of course, we probably will at times want to, like most of the time we're going to be querying, we are going to be putting together this data like this. Putting together these queries like this. So we've got our bool, which is wrapping both of these terms in here. And we have, we're saying must match. Must is essentially like when you combine things together, it's an and. Elasticsearch also uses should. That's the opposite. So that would be like an or. So you can do either must or should match. For example, here, it must match Big Park. So that's our query term, and you're seeing we're getting, now we're only getting things that have a feature class of L. And then it's giving us, we've got our max score of 8.375, blah, blah, and then, each of these is scored as relevancy. So it's giving us back the most relevant hits. And now I'm going to switch back to my slides real quick and talk about a few more things before we get into the most interesting data point. Another thing that I want to show you are the aggregations. This is going to be really important, especially if you're just trying to see what type of data you have. An aggregation is like a group by. So this group by, it just puts things in buckets and gives you a count. So these are what our feature codes are that are available to us. So you can kind of see that. That is obviously a useful feature, especially if you're exploring the data. I've written several apps that have, like some data exploration things where you're doing a lot of aggregations and showing people, okay, here's what's in there, and then letting them, choose one of these and drill down. So what are the benefits of using Elasticsearch even without throwing in the geo searching, which I promise we're about to get to? It's really fast, like I showed you. In this case, it was over 100 milliseconds. Just because I think I had so many results. Earlier, I was running about 20 milliseconds for queries, but either way, that's really fast to search text data and get that back to you. And there's some other things, other types of searches. Obviously, we're going to move on really quickly to the geo searching, but there's some other really cool things that you may want to look into. One thing that I really like is the more like this. So if you find some data, a document that you really like, and you want your users to be able to say, okay, I found something that's interesting. Now go help me find things that are like what I just found. You can help them kind of explore on their own by doing a more like this search. So if you just bring that into the, if you just look for that in the Elasticsearch documentation, it's a very cool and useful feature. And I just wanted to show you real quickly here what I'm doing with loading the data. Remember when, oh, and just for your reference, this is actually written in PHP, but you don't really need to understand all of this. I'm just wanted to show you that what I'm doing here is a bulk insert, and I'm preparing this bulk JSON. So when I said that Elasticsearch is read optimized, it's important to know that that means that you don't want to be sending like 1 million transactions to it just to load the data. That's going to slow things down with it. It's not going to like that. So what I did here is just a real quick and dirty. Okay, I've got, once my location count gets over 1,000, I send the 1,000 records to it to upload it. This runs much better, and it doesn't take down your server. Of course, there's the tools, the built-in tools that they have for ingesting data. So those might be useful too, just to help you get the data in there in an efficient manner. So, we don't really need to go through this code, but I just wanted to, kind of put it out here for your reference so you can refer to it later if you'd like. But all we're doing here is just bringing a, going to port 9200 and, putting it in JSON. Okay, now let's get to the most interesting piece, which is searching by location. I'm going to just give you a reminder here. This is the type of search that you could be doing that we're ultimately going towards, which is, okay, we've got our query, latitude, longitude, radius. Let's see here. I also have another a polygon search, which I think is very cool. I'm going to get over here. So here we've got a list of points. And then I run this against this this PHP API that I wrote, and it's actually packaging these up and sending them to Elasticsearch, and then showing you everything that is within these points. And then of course we could do more with that. We could send in text searches as well. We could also we could just get other metadata out of it and do other sorts of filtering. Maybe we wanted to know the elevation or the feature code or whatever. So anyway, I'm going to get back to my Cabana window here. Okay. And so this is, here is a basic geo search. So again, we are looking at our index. We have a document type of location, and now we are running a search. You can see here that this is a query. We've got our bool operator again. The reason we have the bool is because we're doing a filter. Why are we doing a filter, you might ask? Well, because we're searching for geodistance instead of actually searching for what should I say? We're actually searching a circle around this point, so we don't have any sort of context as far as what what's the closest point to us. But this is just actually basically drawing a circle of 25 kilometers around us and bringing back. Okay, there are only four things close to this. I'm just going to go over here to a map. Just out of curiosity, pick a random point here. I honestly don't know where in the U.S. this map was, but I'm just going to use this just to give you an example of you're building some sort of application. You've got your map, and then your user is in this location. It sends in their latitude, longitude, and then you pass that through here. Okay, so there's, at this point, it found 773 things close to this within a 25 kilometer radius. And of course, this also takes miles if you are in a country that uses miles versus kilometers. And I believe you can also search in meters if you just do this. Let's see, that would be 2 kilometers, 2,000 meters, little radius. Okay, so there wasn't as much found there, but it did find something. So those are the different ways that you can search for distance. But again, that's just, bringing in your data point and then drawing a radius of whatever this distance is around that data point, and bringing back everything within that. So I'm sure that that's nice, but you're also going to want to combine it with your text search. So here we're using the must because we want to actually search on this and then filter by that radius. And you can chain together different matches. You can also have different filters. So I can also filter by some other data point. I'm going to bring this latitude and longitude in. I only got a chance this morning or today to load 1 million records. The full data set has, I think 3 million data points. So I didn't, some of the latitude and longitude I was testing with last week aren't in there yet. So anyway, I've got a point here, and I'm, I found something, and, I searched on park. Let's see if I got rid of everything again. Luckily, we have some undo. I'm going to get back to that. Sorry about that. Okay, where am I here? Okay, so instead of park, I'm just going to search by, stream. Okay, no streams within 25 kilometers of this data point. Maybe there's a school. Okay, yep, there's a school. And you can see here, now, unlike up here, this was no score because it's just, we didn't tell it how to do this other than the filter. So now we're actually searching for text here, and we have a score of, let's see, 2.54. It doesn't, like I said, that's not really relevant, except for the fact that, you can compare it to these other things. And you can see here, because these numbers are pretty close, it's thinking that these are relatively similar matches. And one thing about Elasticsearch is it's really good about filtering out common words like the. It's not really going to put the in the query very much, because anything that is really a commonly used word like that, it has algorithms so that it won't actually affect your searching. It's not going to search everything that has an A in it necessarily. It's just going to still it's just going to use that as, okay, this is a way too common of a term. So let's see here. Let's move on. What else do we have here? Okay, this is a now we've talked about searching around us, but what if we want to actually know how far apart these are? If you look at this, we don't have any reference point, so we don't know how far this is from our point. We just know, okay, this is within a certain, we know it's within a certain radius, but it didn't tell us anything about, okay, how close is this to us? So at this point, we're going to want to actually sort by geodistance instead of filtering. So we're still going to run our query, and then we are going to run a sort. This geodistance, we give it a latitude and longitude, and we're location point. I just wanted to remind you that location point is the name of our point in our data. Now, that's not something that's defined by Elasticsearch. That was defined by us. Sometimes in the documentation, I found that's a little tricky, so I just wanted to point that out. And we want to have it ascending, so it's going to give us the stuff that's closest to us. We're doing kilometers. We want the minimum distance, and this distance type of arc. There's two distance types. I'm blanking on the opposite of arc. I think it might be plane, but I'm not sure. I'd have to look at the documentation to see for sure. But arc is going to basically account for the curvature of the Earth. So it's going to be more precise, but it could take a little bit longer if you have a lot of data very closely together. In this case, we're still getting queries within 95 seconds. I'm sorry, 95 milliseconds. So it's really not affecting us when we only have 1 million records. But if your database had hundreds of millions, and you really wanted, you're having performance issues, and you don't care too much about your how precise it is, as long as it's good enough, you could change that to searching on a plane. The other thing about this distance type is arc is going to be more accurate the closer you get to the North or the South Pole, just because of issues with the way the Earth curves and stuff like that. Luckily, they have mathematicians and mapping experts that have figured all that out for us, so we don't really need to know, other than the fact that it is something we can look into and change if we want to look at different results. So if you see here, we are actually getting things that match park, and we're actually sorting it by distance. So this number here, this is the number of kilometers away this point is. So if we switch it to miles, we can see, okay, it's 31 miles. Or 51 kilometers. So, and you also notice here that even though it's putting this query in here, it's not scoring it because we've told it, okay, you score it for the relevancy of showing it to us. And this is one place where there's a little bit of magic going on behind the scenes that we probably don't, unless you looked at the source code and really understood it, you might not totally know how it's running this, but it doesn't show you the score anymore because it scored it, it brought back some relevant results, and then it sorted it by distance. And how it combines those two, like I said, we don't really know the total details, but it's, from my experience, it's done a very good job of melding together what your distance is versus your search itself. So you can see here, and now we know how far away this is. I'm just going to bring back this other data point that may have a little bit more data nearby. Yes, so I'm getting more parks close by. So you can see here, it's sorting these very nicely. And of course, we can do other queries. We can also throw in a filter here if we put this inside a bool. So we can really build this out to be a very full-featured search based on the tools that we've talked about today. Now, the last thing that I want to talk about is this polygon search. So before this, I just kind of went and got some random data points here. I'm just going to throw one more in here. And show you that you can actually pass in, you can do a geo polygon search. Let's see here, get the correct syntax, get that longitude, and it's warning me here that I need to close my bracket and run that. And so now what we've done is, again, you'll notice that this is a filter. So we had to put in the bool. So we've got our must match. See if there's any rivers. Okay, there's, okay, I found two things, New River Post Office and New River #1 mine. Happen to be within these points that I kind of randomly selected on the map. So you can see you could create a mapping application where you let your you let your user create points and then draw some sort of box. There's actually and if you're just doing a box, there's a way to just bring in let's see here. I just wanted to show you here in this documentation. As you can see here, there's a lot of good examples. Sorry for all the scrolling. They also have the geo bounding box, which is another way. So you can just give it a top left and a bottom right. And in our case, this would be location point here. So that's another way to search. But anyway, I think this is really cool. You can build some sort of front end where you let your users draw on a map, or select points, make some sort of polygon, and you can say, okay, now I know all the things within that. And of course, you're returning this latitude and longitude, so you can plot those on the map itself. So I'm just going to go back to my slides here. And let's see, I think I have 2 more minutes. So the last thing I wanted to mention is not about geo-searching specifically, but I talked about how you may want to start adding in, letting your users comment on a location as part of this application. Well, I just wanted to show you here that you actually can, actually do a put to the mapping. If you remember way back, we did a put to just the index name. It didn't have this document type or this mapping yet, and that's what created it. But if we want to add something to a mapping, we can just specify just the property that we want. So that's actually really useful. The other thing that Elasticsearch does that's helpful is if you post in data and it sees fields that it doesn't, it will just try to figure out what that property type should be. It doesn't necessarily always do a good job at it. If it saw something like latitude and longitude or text, it's going to be pretty good. But it's not going to know, okay, well, this looks like it should be a keyword versus text. It might not guess numbers right, or the type of number, whether it's a float or an integer. So those are just some things to be wary of as you're putting in your data. But the nice thing is it's very easy to add fields to your application. Just one other thing as you're talking about, okay, you're adding a list of comments. Elasticsearch does things a little bit differently when it has an array of objects. So if you so you actually cannot search the child objects and then get the parent in the way you would think. So they have a nested data type to help you with that. Just in case your use case, you need that to be there, you would then create like a comment list nested data type and then put a comment text field underneath that, if that's how you wanted to search. So I just wanted to warn you about that. And I'd like to thank you for listening today. I hope you got some good information.
Yeah, thank you, Derek.
You're welcome.
So it was, at least for me, it was interesting.
Oh, good.
but I think to the majority out there, it applies the same. So I would like to feed you with questions coming in. Yeah, and I start with the following one. Can I chain commands in Match? How much influence does that have on performance?
Okay, yes, you can chain together commands. For example, with the must or the should, you can you basically have to put together different matches inside a bool. And I haven't seen any real impact on performance. I've put together searching for a number of different types of text, like an OR, and it really it still brings back stuff in, hundreds of milliseconds. So I haven't seen any big performance. Some of the biggest data sets that I've used for this is about, 10 to 20 million records. So I haven't gotten, huge like billions, but, still good sized data sets, and I haven't noticed any issues.
Okay, thank you, Derek.
You're welcome.
One please from my side. You can now stop the presentation, so
yes,
that we see yourself as the presenter more on the central.
Yes, thank you for reminding me.
Because I think
there we go.
Nothing more to show.
Yes.
Respect of yourself. So what interested me is whether you can highlight a little bit to us your thoughts on the use cases of what you just showed. So where you have seen it already, where is the market demand for this geospatial topic coming from in your eyes, and also the tagging angle.
Right. So I think that one of the ways that I see this being really useful is with the rise of mobile apps. I mean, that's not something new, but at this point, we all have mobile devices on us, and more web searches are being run by mobile devices, which means that we're getting that we have access to the user's location. And so searching, just like Google Maps will show you results based on where you're at. And searches for, coffee shop near me, that type of stuff is really, it's really, useful, something that people search for a lot. So I think that, whatever your application is, for example, I've done some work on a fitness app where we're mapping the person. We could actually and they're actually for a gym class, so we actually could we haven't done this yet, but a particular use case could be mapping together, okay, well, where is how close are the different runs happening, what's near there, what did they run by, are there any interesting landmarks that that they've seen. That's another one that you could do is you could do something with, okay, you're traveling around, what's nearby me that might be of interest to me. And whatever your app is, whatever that domain of knowledge that you have, you could apply that to, okay, if you can get the location of what you're searching for, you can give more relevant data rather than just saying, here's landmarks. And we think those are in, and based on the text, we think they're, in Austria. You can say, okay, well, I know specifically this is, 10 kilometers from where you're at right now. And I just think that, can be hugely important. One other thing that I had been working on, and it actually got stalled out just because of the pandemic that we're in right now, and people aren't going out and visiting stores anymore. But I was working on an I didn't start building it yet, but I was working on the ideas of an app where you're soliciting like donations from for a nonprofit. One thing that they would do a lot is go around to local businesses and say, do you have anything to give us? And we're going to auction it off for us. And it was a big thing to organize for all the people in this organization to know, okay, well, they would have to look at a map and say, okay, well, you can take the businesses on this street and I'll take the one on this street. So I was actually envisioning an idea where you would actually know, okay, these are the businesses before me, and I can actually look up in like a customer, in a CRM system and say, okay, I know that they gave to us last year. And you could do this just for sales too. If you're going from, I'm sure there's not too many door-to-door salespeople anymore, but if you were out there, talking to people and it's like, oh, okay, well, this business, was a customer of ours, or this business donated to a cause that I like. Maybe I'm going to now, go and buy something from them because I really like that they supported us, my school or something like that. So that was kind of the one of the domains that I was in. Working towards. Hopefully someday that project will be revived. If not by me, by someone else, now that I'm saying it out loud.
Good, thank you. So a couple of more questions. Actually, the following is also I have had in mind. What led you to looking into Elasticsearch particularly for this?
I actually started with Elasticsearch. I was working for an e-commerce company, and they actually did online reviews. Had like little widgets you could plug into your website. So some of the big retailers used it for for providing reviews. Well, you want those reviews to be easily searchable. And so that's how that company started using Elasticsearch. And that's how I got introduced to it. But then when I started looking at other features in there, I just really was like, oh, there's so much more that you could build with this other than just the text searching. I think that text searching plus the other things just makes it really, really powerful.
Okay, thank you.
You're welcome.
And can Elasticsearch return only fields where search data occurs, or similar to Google search results pages?
So if I understand correctly, so if you're talking about if there's just like some text in there and it has a lot of stuff about you can actually, I believe there's a way to actually put tags in there around it, so you could actually have it highlighted just like a Google search would do. So you would actually know where your specific term is. And then there's also some other ways. I'm blanking on the actual, the other types of match, but there are some more specific matches where you're not just looking for, I guess it's a keyword match. You can still do a keyword match on a text field. Might not be quite as relevant, but that would only give you something exactly like that versus a more fuzzy match. You can also dial down the level of fuzziness, or dial up the level of fuzziness in the matches. There's a lot of different parameters you can send with your search. So you can say, I want things that are more specific or less specific. And then that can also tune your results.
So, and the next one's coming in. In your opinion, is Elasticsearch another part of a semantic web, or is it because there is no semantic web?
Yeah, good question. I hadn't really thought of that too much. I don't know if I'm necessarily qualified to know if there to say if there's a semantic web or not. But you could certainly use Elasticsearch for, I mean, what it's good at is, bringing the semantics out of the text, essentially. So yeah, I mean, I think that maybe it's good at, providing some of those features, even if they aren't, given to us by developers and stuff, because it just really, it lets us tame the text, essentially.
Yeah, okay. And if not Elasticsearch, what would you use? I can give you a hint, Derek.
Yes. There we go. Couchbase. Yes, I know. Yes, I haven't personally had the opportunity to use that yet, but I think that it's actually, any of those document database stores like Couchbase are really useful for this type of text storage and text searching. So there's a lot, and I know that there's also the Apache Solar project as well. I touched on it briefly, but I think that the money was kind of behind the Elasticsearch versus Solar. But I know there's some really big companies using Solar out there, and of course, Couchbase and others are really, really pushing the limits, I think, that of what you can do and search with text, which I think is just really, really great, because we have so much data that we're storing.
Yes.
And another application that I had was just kind of a data exploration site, because we would get millions and millions of records from our customers, and they said it was in a certain format, but it wasn't. So we actually built a tool for our customer service people to look into the data and see, okay, well, what did they really give us? And, tools like that were really useful, because it let us, we weren't confined to a relational database structure, because we were getting semi-structured data versus, highly structured stuff that could go in a SQL statement. So yeah, I think any of those tools are really good for that type of application as well.
And the last sentence of yours you just said is a perfect transition point to the very last question. Are you aware of how does the performance compare to Postgres and GIS?
That I actually don't know. I haven't. I have used it a little in Postgres, but I haven't had an opportunity to use it on really large data sets like this. I know that just in general, the performance has been really just awesome. So but I honestly don't know how it compares.
Okay, no problem.
All right.
Good. So I think we are at the end of this session. So Derek, really, thank you really much again from my side.
You're welcome.
I was glad.
Yes.
I'm glad to have you here. And to the audience, this session is then now over. And you can rate this session, as you can rate every session after it happened, on the right-hand side next to the stream. And I also want to emphasize again that you can win one of 3 vouchers coming from Couchbase, sponsored by Couchbase, €200 for Amazon. And this was it here with Derek, and but not for the day, because the next session is all about leveraging cloud computing benefits with serverless multi-cloud machine learning, powered by Women in AI and Linda Mohammed. And I'm looking forward to see you all there again.
Your app just crashed. It was struck by a hammer manufactured in 2005 by Harry's Hammers. The hammer's head is composed of 75% nickel, 20% steel, and 5% iron. Curiously, a hurricane just came down in Iran.
So here we go again. Hello, everybody, to our next session, Leverage Cloud Computing Benefits with Serverless Multi-Cloud Machine Learning powered by Women in AI. And exactly this crowd I have here around me. And Linda Mohammed will lead this session, but before we will hear also just a little bit about women in AI. Just two hints for you guys. To create this session more interactive, please do use the window on the right-hand side to the live stream window. You can enter there your questions, so Linda can answer this then in the Q&A session. And at the bottom of the live stream, you find the Couchbase banner where you can participate in the game to win free or 1 out of 3 Amazon vouchers composed of €200. So it's up to you. And I wish you much fun in the session.
Thank you, Stefan, for introducing us. Hi, everyone. My name is Karina. I am Ambassador for Women in AI, and I'm here today with Sanja and Linda, and who will introduce themselves afterwards. Women in AI, why is this important? Today, you know, AI is basically part of our lives. It helps us to figure out which movie to watch next, and also how to find the fastest way from A to B. And it's even used for much more important decisions about our lives, such as how long we should go to jail or whether we are granted a loan or not. However, today, only 22% of AI experts are women. And that's actually what we want to change. We as women in AI have the mission to increase female representation and participation in the field of AI. And in this way to make society more, benefit society as a whole. So this is our global NGO. We are operating in more than 115 countries. We have more than about 5,000 members, and we are very active all around the globe. Here in Austria, we recently launched our national NGO, Women in AI Austria, and we are a team of highly motivated women trying to have super cool activities for our communities. And this is actually what Sanja is going to introduce to you. She is our Vienna city lead, and she is the head of activities here in Vienna. Please, Sanja.
Perfect. Thanks, Karina. So a very welcome from my side as well. Thanks to WeAreDevelopers for hosting us as well here at this stage. I actually just really briefly want to go over what is coming next. So in case you're interested in AI, actually it doesn't matter if you're female or male, but if you're interested in AI and you really want to push and kind of join this community, feel free to do so. Basically what we want to highlight, we've planned several things for next year, but what we want to highlight is basically the community part. So there will be some virtual events happening, basically from virtual networks, more the lunches. So it's going to be informal, it's going to be really fun, and just something to share and increase your network. We have different events where we as Women in AI Austria also support and contribute. We have Women in AI Accelerate Europe, which means that if you're female, if you're going to start your own startup with an AI focus or and part of it, just keep current, keep informed, and yeah, we're gonna support you in this aspect. And then also there are gonna be some events based on education. So we're gonna have some web series based on AI and freedom of expression, but also some educational streams where we want you to learn more about data science, about AI, and how to get started in the end. It's not only organized by us, but we're gonna support it. But in the end, it's really supported by various sets and yeah, communities within the data science community in Vienna. And lastly, we also have some publications that we want to promote here. We have, as Karina said, we have highly motivated people in the team that are eager to share what they're working on, what their goal is, and this is basically going to be pushed and promoted on Medium, but also on LinkedIn. Coming to that, how can you join? So now you're interested. I'm pretty sure basically go to womeninai.co to join as a member. As Karina said, we have more than 4,000 members. It's a global network. We have, I think, over 100 countries now that joined, and a lot of partners as well. So make sure that if you want to have the benefits of the community, to join womeninai.co. And lastly, follow us on LinkedIn. We posted the QR code in the slides. So make sure just to, I don't know, turn on your camera, visit the website, and then this is actually where we're gonna host and like post all the events that we're gonna present and work on. And lastly, this is the Austrian community, the Women in AI Austria community. We recently, as Karina said, joined or like created our own non-profit organization in Austria. And if you want to support us, either through becoming an active member or through becoming a company partner, just support and send a request to Karina at womeninai.co to get more information on how that works. And lastly, to not like take over the time of Linda, we really want to make sure that you join later as well. We'll have a great discussion on democratizing AI. So making sure that whoever wants to be part of AI or wants to do something with artificial intelligence can actually start with that. And yeah, basically see you at 6:15. And with that, Linda, the stage is yours. Thanks again for creating the Tech Talk, and I'm super excited about it.
Tanya, thank you very much for the introduction of Women in AI. So I will quickly take over to present my slides. So, and I hope you can see the slides now. Yes, I guess it's working. On the live stream, I think you can hear me 10 seconds later, but I hope this isn't the problem. So, hello, everybody, and welcome to my presentation on how to leverage cloud computing benefits with serverless multi-cloud machine learning. Yeah, as you can see, I tried to use as many buzzwords I know, maybe because of the fact that I am a consultant, but of course I will try to explain you all of the things that probably be new for anybody here. So quickly to have an overview of what I will be talking about. So it will be about emerging technologies and how you can learn basically anything, and also what my approach is. Then I will talk about machine learning and how you can get started with it. And last but not least, I will tell you what democratization means for me, so what my understanding is and how it relates to cloud computing. So for all of the people who don't know me, and I guess there are some people out there who don't know me, except of my colleagues and friends. So hello at this point. My name is Linda Mohammed, and I'm working in the IT since 2008. This is the time when I started high school. So to be concrete, I attended the HTL in Pinkerfeld in the field of informatics. And since 2013, I am working in the IT. So I started as a client engineer at Hutchison 3 Austria, where I did the Windows 7 rollout at this time. Yeah, and part-time besides work, I studied business informatics. Yeah, during my studies, I did like a lot of different things in the IT department. I worked as a Java software developer and also as a business analyst. And when we were like agile, then I started as a product owner and did also some things as a Scrum Master. But yeah, some facts about me. I told you that I was working as a software developer, but I wouldn't call myself a software developer. I would call myself a prototype developer because I lack patience for more somehow. Yeah, I would say that I can learn anything as far as I can ask someone or when there's a documentation. And among creative IT, where I'm working at the moment, so I'm senior consultant for cloud technologies, I am declared as the process nerd. And if you would ask my colleagues what they would say about me, they would describe me as ambitious, process and documentation oriented, extremely motivated, and the synonym of agile. Thank you for that. So coming to the talk, I am a friend of expectation management, so I will quickly give you an overview of what you can expect from this presentation and what you shouldn't expect. So first of all, I will try to give you a basic understanding of the concept of machine learning. Then I will show you some of the products and services which are offered by public cloud providers. You will probably have an idea on how a machine learning cycle could look like. I mean, there are different solutions. And also, I would like to tell you what democratization is about and how it relates to cloud services. So what you shouldn't expect from this talk is getting a deep dive into different algorithms and statistical operations, as well as getting detailed information of how every single cloud service works that is being offered, because there are really a lot of them. And yeah, there's probably not only one solution for a problem. I guess there are more. And also, not everything works as expected, but everybody in IT probably knows that. So then I would like to start with some terms, because maybe there are a lot of people out there which are, I don't know, maybe new to IT or don't really have the terms in their head. So first of all, I would like to talk about computer science, so the abbreviation for CS. And yeah, let's start with some theory. Yeah. I didn't study computer science. I studied business informatics, but yeah, I also know what computer science is, but I would like to tell you what this is. So actually, computer science is, in a nutshell, doing different stuff with data. And as we know, it's all about data. And this brings us to the next term. So as we see here, computer science is the science of the systematic representation, storage, processing, and transmission of information, especially automatic processing with digital computers. And when I say everything is about data, then we have the second term, which is called data science. And data science is an interdisciplinary field that uses scientific methods, processes, algorithms, and systems to extract knowledge and insights from many structural and unstructured data. So, okay, it's all about data. We need some experts if we have a lot of data, and those experts need to get the insights from this data. Okay, cool. So, but I told you that I will talk about AI. So what about AI? Back to term clarification. What is AI? And don't be afraid, I will get away from the theory soon. So AI is basically the concept of using historical data and human experience to solve problems. So it's a branch of computer science that deals with the automation of intelligent behavior and machine learning. Yeah, so when I started to do the slides for this presentation, my colleague sent me a funny picture, which also describes machine learning very good. It's a picture from a computer science lecture about intelligent systems. So changing random stuff until your program works is hacky and bad coding practice. But if you do it fast enough, it's called machine learning and pays you 4 times your current salary. It's funny because it's true, or it could be true. Yeah, so I told you a lot of things about different terms and practices in, I would say, information technology and everything that's around computers here. So we have computer science, which is basically engineering. Then we have information technology, which is usually business operations. So in information technology, we're trying to solve business problems in a nutshell. So then we have data science. Data science is a lot about statistics and maths. And to be honest, that's not my field of expertise, but I wanted to try it and to try different stuff to solve problems without being the expert, but I will come to that later. And also what would be needed to really apply machine learning is the domain expertise of the specific problem you would like to solve. When we have a look at this, yeah, that's a little bit overwhelming, and I won't talk about everything here, but I just wanted to show you that there are really a bunch of different things which are considered as being computer science, information technology, or data science. So, for example, data science is about data mining, experimenting and design, domain research, visualization, statistics, and stuff. And for example, computer science is a lot about algorithms and different computer systems. And one of the areas of computer science is artificial intelligence. And one of the areas of artificial intelligence is machine learning. And there we have different approaches. So we have supervised learning and unsupervised learning. We would have also have reinforcement learning if somebody knows it, but I won't get into detail. And we also have deep learning. And just to have this complete, I will also tell you what information technology is. So it's actually, yeah, solution design, for example, if you're trying to approach a problem and you're designing the solution for that. Also web development, everything about networking, storage, business analysis, and of course, public cloud, which is a really important topic for this presentation. But to keep this a little bit shorter, I will today just talk about machine learning, supervised learning, and a little bit about deep learning. But let's go back to the topic of machine learning. So we're back at the term definitions. Before we get started with the details, what is machine learning? So as I already told you, machine learning is a part of computer science. So, and it's the study of computer algorithms that improve automatically through experience. So the thing is that, as I already told you, AI or machine learning is a lot about historical data to use, and also human experience to use to get better at something or to make a system getting better at something. If we have a look at a possible machine learning cycle, at this point, thank you very much to a Cloud Guru, because I used the overview which you showed in the machine learning training. So thank you very much. First of all, you start with fetching some data, and then the data you got, you have to clean somehow to prepare it for training the model. If you trained the model, you have to evaluate the model if it works as expected. And as I told you, not everything works as expected. Then you would deploy it to production, evaluate and monitor it, and the same again. So you always have to improve your model, and you always have to stick to the practices to make this better and better. And as I already told you, everything is about data. So really, it's all about data. Data collection, data preparation, and then doing training, evaluation, and optimization with this data. So why I use different data zones here, I will explain you shortly. But first of all, we have one more step to scale the whole data preparation stuff, and I will come to every point here in detail. So the other step we need is the training for pre-processing. So if you have a look at my, if you had a look at my talk details, you probably recognize that I'm using Azure Computer Vision Services now for the pre-processing. That's simply because it was easier and more efficient to use in comparison to the Google Cloud services, which I wanted to use initially. But I also used the Google Cloud Auto ML service to train the model after doing all the preparation and cleaning stuff. But first, before we get started to solve the problem, it's really important in machine learning, or it's important for solving every problem or any problem, that you just have a quick look, is there already a solution for my problem? So what we get started with is actually the point 0. So we are trying to find a solution for our problem. It's basically done with Googling stuff, of course. That's what we're doing in the IT a lot, I would say. And yeah, I found actually a model which was already pre-trained from somebody on the internet. And the problem is, so wait, I have to start again. So if we do some quick research on machine learning models to detect juggling patterns, we find the pre-trained model for the different patterns. But this model only works with juggling background, like one color background to use it. And also, if we continue research, then we see a lot of theoretical stuff. So many people had thoughts about this problem and already thought about how to approach this problem in a statistical or mathematical way, but that's not really the thing I would do. So in a nutshell, there is already a trained model, but we cannot use it. And there's also a lot of theoretical research. So the next research topic, we would like to solve this problem of seeing people juggling and seeing also different juggling patterns, and also to like analyze if a person is juggling or not. So how we could do this, as I said, there is a lot of theoretical stuff about this, but it's a lot about maths and complicated decision trees. And as I already said, I studied business informatics, but not computer science, and definitely not mathematics. And that's something I would not go for to solve this problem. But if we have a look at this different juggling patterns, then we can see that we as a human can see the different patterns, and we can also see the different devices or stuff like with the people are juggling with. So we have different stuff that you can juggle. So for example, we have some juggling balls, and I don't have juggling clubs or rings here in the office, but yeah, juggling balls. But in a nutshell, so we have to analyze the juggling patterns, but it requires a lot of maths. So we're trying to use computer vision to solve this problem. But to be concrete, we will use object detection to solve this problem. So coming back to my architecture slide, as I already told you, before we start with the machine learning process, we will start with some pre-processing. And for this pre-processing, I trained a custom vision model. So custom vision is a non-code service offered by Azure, where you can really easily easily train a model, but it's like really time consuming. It basically works the same as the AutoML service works from Google Cloud Services. And I will show you a short video on that, because that's what how I started with. So basically you have to label like everything. I started with labeling the different objects I have, like I have the balls, the clubs, and the rings. And then I also have the different types of what I can do with those objects. So for example, I can hold a ball in my hand, and I can also throw a ball. So for example, if I would juggle, then it's a difference between I'm holding the ball and I'm throwing the ball. So I also decided to differentiate between those different statuses. No, features, let's call them features. Those are the different labels I use. So ball in hand, club in hand, and ring in hand. And also there's a person which is juggling. As you can see here, this takes a lot of time, and it's totally not scalable. And you can also see here that I did this for 20 minutes at least. So 20 minutes I recorded, and still it was not trained enough so that I could use it. So does this scale? Obviously not. Then the next thing, we have to collect some data. To collect some data, you could either go to Google and search for some images. I will show you some examples later. Or, for example, we would like to have some user-generated content, and user-generated content you can get from Instagram, for example. But this content is blocked until you log in. So I had to do a quick workaround to get the different data. And I just used a Chrome plugin, which is called Web Scraper. And there I can just generate a CSV file, which helps me to do the pre-processing for the next steps. And this file will be stored on a Amazon S3 bucket. And then I will show you the next steps. But back to this, does it scale? No, it doesn't scale because it's like still a lot of work. Well, then I thought, okay, I can automate that stuff. That's not that hard. Yeah, I thought so. But it's in reality a little bit harder than expected, because when I started to automate the feature engineering part, I will just call it feature engineering as a whole. The first iterations went pretty well until the recall really went down. So second iteration, that's good. Third iteration, also good. You can see that I have some of errors there. This is a screen from Custom Vision AI, so it shows you really good evaluation of the data. And yeah, you can see from the iteration 7 to the iteration 8, I had a problem. Why did I have this problem? Because I trained the model with user-generated content, as I already said, but I didn't clean the data. So I just pushed the data from Instagram, from the hashtag juggling, directly into my model, and it didn't work out pretty well. So pre-processing your data is really important. But why is this important? I will just show you some examples. If you have a look at some data sets for example, in tutorials, you would see probably something like this, what's pretty fine, it works really good. Or you can see something like this, also works good, I guess. Or something like this. I have no idea what he's juggling. I think that's a stone, but that's fine, that's fine. It looks somehow like a ball. I think that would be fine. But then in the wild, we also have other data sets. So this and that and that, and here the stuff. And yeah, I think this person is juggling, but I cannot really tell. Yeah, then we have something like that, we have something like that and that. Okay. Pretty much that's always about juggling, but it doesn't really help us to train our model. Especially the last picture is could be a little bit complicated for a machine learning model, because yeah, I think you would totally mess this up. So what do we have here? We have some user-generated data tagged with juggling on the left side, and we have some images from Google search on the right side. But as you can see, both of the content is like, yeah, useful for some reasons or not really useful for some reasons. And for example, if we have a look at this, if I would have to explain the process which I did at the moment, this would be the feature engineering part. So we need our intelligence to look at the pictures and to see which pictures we can use for training the model and which we can't really use. So on the left side, you see the useful content, and on the right side, you see the less useful content. But again, does this scale? No, not really. So when we come back to our architecture or the overview, what we're trying to do. We already talked about the data collection part, which is not really scalable at the moment, but I'm trying to improve that. So we're fetching the data with the web scraper, and we're we're storing this in an Amazon S3 bucket. So basically what we're doing in the data preparation part, or in the cleaning part, let's say, is that we collect some image URLs from the web scraper, which we stored in the S3 bucket. And then we're using Azure ML. So that's a machine learning framework from Azure to clean up the model. How did I do that? I trained a custom vision model for pre-processing, and then I just deployed it to the cloud to use it in a different way. Yeah, we can tell if this is good or bad, or I don't know, but I was trying to solve my problem of pre-processing data and not to make that too time consuming. So if we have a look at the cleaning part, what happens here? So if, for example, a new image URL is saved to a S3 bucket, then a CloudWatch event is triggered to prepare the data. I will come to the data preparation later, but everything you can see here are cloud services. So all of the icons here are cloud services. The custom vision AI is a Azure service, and nearly all of the other things. No, S3 is AWS service. CloudWatch is also AWS service. Azure ML is Azure service. Then the preparation icon you can see there is the storage from Google, and so on and so forth. But now we can go back to the cleaning part. So you can see here just a screenshot, because I didn't want to add the whole video here, because I think that would be a lot of information. But actually I just used the pre-trained model to get the information about what happens on the picture. So what can I do with that? With the information on the picture, which I get from the Azure ML service, I can format a CSV file, which is needed for AutoML, which is the Google service for image recognition or object detection or custom vision or computer vision, as you would like to call it. Yeah, and it needs some it needs some CSV file to do the training. So back to our workflow for the data preparation. What did we do now? We have the model for the pre-processing, which we are using to clean the data. Then we have the S3 bucket where we have all the image URLs. We have an Amazon CloudWatch event, which triggers an SQSQ. This is a messaging service from AWS, which triggers a Lambda function in the background. So the Lambda function is doing all the stuff which is collecting the image URLs with the prediction response, which we did before. And then it generates the CSV file in the background and sends this CSV file to Google Cloud Platform and stores it in the Google Cloud container. I don't know what the exact name is of it. It's like S3 bucket, but on Google. So there is a little bit more happening, but I tried to keep it really simple. And when people are asking me, oh my God, will AI take over the world? I wouldn't say that. Because, for example, I told you the training of the model, which I did in the beginning, and this was manual training. After the first iteration of training, my AI told me that I am a ball for 29%. Maybe that's one of the reasons why women are not really going into information technology. Yeah, but it also said that the Florido Tower, which you can see from our office here, is also a ball. And there is another funny picture, which my AI currently showed after 10 iterations of training. Yeah, that's not a ball in a hand, but it's a ball, basically. But jokes aside, it works pretty fine with all the pre-processing and stuff, but it didn't work fine if when I kept the pre-processing beside. So that's really an important thing to have in mind if you train a model. The three pictures you see is on the left side, it's the test from Azure Custom Vision. Then in the middle, you see the Google Cloud Platform AutoML model, which I trained during this process. So the left one, the Azure Custom Vision model, I used for the pre-processing, where I did a lot of manual training, but also did the training where I didn't pre-process the images before, but it's working a little bit. So it's working good for the pre-processing. And on the right side, you see the response of my local test. So locally, I have a Docker container running where I can test all the stuff also, because we all know that cloud services are up 100%. Wouldn't say anything else. So coming back to our machine learning cycle. Yeah, when we train the model, here you can see the evaluation of training the Google Cloud Platform model. I would really like to explain you that in more detail, but it's really not my area of expertise. And I would be happy if somebody could explain me all the training and evaluation data, because there are a lot of things which I just did manually. So, for example, also the evaluation of the training was not done automatically. I just had a look on what did I train at the moment, was it getting better or was it getting worse? And I was trying to just automate all the stuff, which is the feature engineering part, because that's really time consuming. And there are many different ways on how to evaluate the model and how you can display that. This is, for example, a screenshot from Custom Vision AI. The previous screenshot was from Google Cloud Platforms. And this model I used for the pre-processing, as I already said. Yeah, then getting to deployment. I may disappoint you at this part, because I made it really easy to deploy all those stuff, and I just exported the model from Custom Vision AI. And yeah, there are many different possibilities to export it, but I just exported a Docker file, so a Docker image, and then I lifted and shifted this Docker container into the cloud to use it again from Azure. So yeah, you can just Google everything, like how to import a Docker container, how to use it in the cloud. There are different possibilities, and maybe it's not the best solution, but as I said, there are many solutions for a problem. And of course, like it's always in IT or in technical stuff, if you know something really well, maybe it's the best solution for you. It doesn't mean that it's the best solution for everybody, but maybe it's the best solution for you. And for me, it was the best solution at this point, because so I could test it locally, because I just had to run the Docker container locally. And I also could test it in every cloud provider I wanted to use. So it doesn't matter whether I would use Azure or AWS or Google Cloud Platform. And as you can see, I get the same results, and it doesn't really depend on where I am using the model. And it works pretty fine. Also, not only with my pictures, but also with pictures from the internet. So, and as I already told you, the monitor and evaluation stuff I did manually, and so I won't show you a lot of things here. But you can also see that the Docker container is running in Azure as well, not only locally. So, and we are pretty much at the end. So what did I tell you? I told you a lot of different stuff about cloud technologies, cloud services. Maybe you heard some of the services the first time. Maybe you are using a lot of the services also for a lot of years, I don't know. But for me, actually, I'm pretty new to cloud technologies or to using cloud services on a daily basis. I started to use the first cloud service I think it was in 2015 when AWS or when Amazon launched Alexa. So we were trying to develop an Alexa skill, and this was done with Lambdas. So I didn't really know that Lambda is serverless technology, let's say. But yeah, I used it some years ago, but since a little bit more than 1 year, I'm using cloud services on a daily basis. So why do I tell you something about democratization in the relation of cloud technologies? Yeah, I will come to that. So basically, what is now really needed to use machine learning or to apply machine learning? I would say a lot of different things are needed. Also, if there are a lot of really good services which help you to use technologies, even if you're not the expert in it, as I'm not an expert in computer science, engineering, or data science, or machine learning or stuff, but I managed to do all the things, and I managed to not to waste too much time. But for example, if I would have a look at this, I have like a little bit or let's say enough expertise and knowledge in everything around analysis and research, because I'm doing this a lot of stuff for requirements engineering and also in consulting. Then I'm doing a lot of experimentation and design of prototypes, and also networking is a really big part of everything that you have to do: storage, web development, solution design, and everything you can tell from information technology. So basically, you need a basic overview of what is needed to solve a problem. But if we would think about what democratization means to me, it's somehow to minimize the experience that is needed, and also to minimize the time that is needed to do something. So if I would try to map this to cloud services, there are many cloud services which I also used for my prototype, and also some more. And actually, there are at the moment about 175 products and services just offered by the AWS cloud. So AWS is like Azure and Google Cloud Platforms, a public cloud provider, if I didn't mention that so far. Yeah, and for me, democratization in relation to cloud services or cloud technologies is, in a nutshell, connecting the dots of technology. So it helps you to get a better overview and a better insight on what you could use. And also, what's pretty important, to do a lot of research and have a look at a lot of different solution designs, how other people do it. Because as I said in the beginning, there's not only one solution for a problem. And last but not least, some learnings and some facts of the prototype. So what I learned during this project: it's really hard to keep things up to date that need ongoing operations. That's also why I decided not to use any manual install servers. It's hard to scale if you don't automate in the beginning. That's true, but I told you that I'm just doing, or that I was just doing a prototype for this showcase, so I wouldn't start with automating everything in my CI/CD pipeline. And also, it's hard to maintain stuff if you manage your custom components automatically. As I said, I didn't have an automated CI/CD pipeline. But what's really cool, learning something new is really fun if there's a documentation, or if you have somebody to ask, and of course, if everything works as expected. Some facts about this prototype. Yeah, no server was manually installed, and also no manual operations for infrastructure was needed. And Also, 50% of the technologies or services which were used, I used for the first time. Yes, I used this prototype or this project for learning reasons. It doesn't mean that I'm not used to a lot of services which are available, but there are really a lot of them. And I love having such fun projects where I can try out new different services. And then I talked about multi-cloud, and yes, I used all of the major public cloud providers, like, for example, AWS, Azure, and Google Cloud platforms. And also, this talk is buzzwords bingo as its best. So as soon there's a Gartner Magic Quadrant for circus operations or relatable stuff, you can also probably make money with it. And I'm finished in 1 minute because I see that Stefan is already here. So the outlook and development opportunities for this project. Of course, as I said, you could build a CI/CD pipeline for the custom components, and you can also think about a more scalable way to do the evaluation and monitoring. And also somebody else, like I showed you in the beginning, trained a model for different juggling patterns, and this can also be used to enhance the functionality, and that also videos can be analyzed, and, for example, to use a better training mechanism. And last but not least, the possible use cases. For example, first of all, you could enable jugglers to do better, to better observe and improve their training progress. Or, for example, you could use it as an open source project to learn new technologies on a fun example. That's what I did. And it would be fun to have a feature for Tesla to measure the quality of jugglers at traffic lights. For example, if you stop at a traffic light and then a juggler comes and juggles during the lights are red, then you can, for example, benchmark this, and then the model tells you how much money you can give him. Thank you very much.
Great, thank you, Linda. Was a very interesting kind of presenting this topic. So I really enjoyed hearing and looking at you and your presentation. Now it's Q&A time. So I feed you with questions, and we have 10 minutes to get through it. I start with the most popular one because the guys out there can rate their questions. So how do you know that the pre-processing works?
Yeah, that's kind of funny because as I already said, first of all, the pre-processing didn't work. So it didn't work because I didn't really do the pre-processing, and then I saw that it's really needed. But how I see that it's working, it's actually also a manual step in the middle. As I said, the evaluation and monitoring of the success is done manually. So I don't have a real let's say, mechanism to automate the pre-processing, so the quality of the pre-processing, but that would be an additional enhancement of the functionality.
Okay, great. So, and the next one is, was the Docker solution your first thought, or did you also try something else?
Actually, first, it was not the first thought because on a daily basis, I'm not working with Docker containers or usually with Docker. So my colleagues are working with Docker a lot. I wanted to export the model as a TensorFlow file and then use it within Amazon SageMaker. But it was, when my knowledge of machine learning is here, it was somehow here. And I didn't manage to do it, so I went for the Docker container.
Okay, practical approach. That's good. Next one is the example of deep learning, or is this example of deep learning because it is computer vision?
That's also a very good question, and I would really like to take this question into the panel discussion, because when I prepared this talk, I was also talking with Sanya, which presented Women in AI on the beginning, and we were also thinking, is this also deep learning, or is, for example, the automation of the whole feature engineering part with a pre-trained model, is this already deep learning? But we're not sure.
Okay, okay. So then I can say to you here, guys, of the outside, looking at us, join the panel discussion in a little bit more than 1 hour with the same women here, and it will be insightful, I guess. Yeah. The next question, Linda, to you is: what was the most challenging part of the solution? What are you planning on doing next with it? So actually, there are 2 questions.
Yeah, so the most challenging part was definitely to use so many new services and also to get used to new technologies. Because as I said, I'm not an expert on this field, and I just tried to read a lot of documentations and also had a look on a lot of different tutorials. And I also did the machine learning specialty certification. So I really tried to get an overview of all of the stuff. But this was really time consuming and also a little bit hard. And also what I think was really the most or the hardest thing for me was the different algorithms. So I know that there are a lot of different algorithms for a lot of different data structures because data is getting more and more and more. But to really apply the different algorithms is really hard, and to know which solution fits to my problem. So the whole engineering part before you are building the solution.
Okay. So, here's some comment to you. Thanks so much. Defining words in intro were great. So your approach obviously is well received. That's great. And here's another one that actually interests me also. It's a personal question. What did bring you into AI and data personally?
That's really funny because you already got to know Sanya, which explained what women in AI is. And when I wanted to start with AI, I just quickly looked for a meetup where I could get some information about what it is. And then I saw that the IT girls did a meetup on computer vision. And Sanya presented the custom vision AI service from Asia. So this was also the first service which I used. And as I already said in the beginning, it's easy to learn really anything. You can learn anything in the world if you have somebody to ask and if there is a documentation. And with Sanya, I suddenly had somebody to ask, and I think it's a lot, great thanks to her that I really stick to it, because we talked a lot about AI and all of the stuff.
Perfect. Thank you for this insights. One more question now, personally coming from me. Maybe you cannot answer it. I don't know, but it's very interesting. You used free cloud provider infrastructure or services. Yeah. Typically, and I don't know whether you are aware of it or not, they charge you with data movement costs. They call it ingress and egress, and you typically pay just for the egress because then the data load exits their infrastructure. What they want to avoid for sure. So combining now these services all together in your solution, what was the cost clock on your side ticking?
Yeah, that's probably also one of the reasons why I used the Docker container for pre-processing. Because it turned out to be really cost intensive. If you trigger an SQS queue from AWS to get some data from Asia and to move this back and forth. So the whole stuff was running for, I don't know, for one evening, or was it one day? And it cost me about, or not me, it cost my company about $400.
Oh, wow.
And that was really a lot. So it was easier with the Docker image, so with the Docker container, I'm sorry, to use it like that, because it's really a lot cheaper. And also I tested a lot locally. Although I'm working a lot with cloud services, but it's cheaper to test when you're still in a trial and error process to test it locally. It's better.
So I see you figured out the best practices in doing that stuff with the cloud providers by just doing it. Yeah, so that's good. That's good. Okay, let me check whether we have another question. Oh yeah, here's one last incoming one. How will AI, ML, data science change in 3 years, in your opinion?
In my opinion, I think that also automation already changed a lot of things in our daily work. And I think that AI and machine learning will come on top of that. So when, for example, at the moment, we change a lot of different jobs so that they are not only technical, but also not only business oriented, but they're kind of both. So we have in many different fields people which are needed to have like a broad knowledge of business and technical. Like I studied business informatics just because of that, because I think that you have to build bridges between business and technology. And I think that AI will have a really good impact on that, because people think that AI will take over the world or will take away the jobs if everything is automated. But you really have to think about, how can you evaluate if something is working? Where do you get the information from? Where do you get the experience from? And where do you get the historical data from? So you need the people, so you need somehow to combine technology with humans so that you can really approach all of those problems.
Great. Okay. Then thank you again, Linda. I think we are now at the end of this session. It was, as I said, very insightful. You have taken us from the very beginning to a full solution. That was great to see such an evolution. And for all you guys out there, I have two important hints for you. First thing is, stick with the Women in AI until the end here at 6:15 p.m. where Linda again will do a panel with her colleagues, and it's all about AI again. Yeah. And also stick with us for the next session, which will start in just 3 minutes, from Arto Liukonen, difficult name, senior developer at NordCloud, with his talk about hate organization your photos. Try it with 5 terabytes at once. And well, you have the possibility now to rate this session here, how well you received the content, the speaker, the presentation itself. You can rate this, and also don't forget to participate in the game with the potential win of 1 out of 3 Amazon €200 vouchers by just clicking the Couchbase banner at the bottom of the live stream. So that's it for now, and enjoy the rest of the evening. See you later, Linda.
Thank you. Bye.
Bye. So here we go again. Hello, everybody, to our next session from Arthur Leoconnen with his speech of hate organizing your photos. Try it with 5 terabytes. And please, again, help making this session more interactive by using the right-hand side window where you can insert your questions related to his speech, and also participate in the game by clicking at the bottom of the live stream section on the Couchbase banner to win €200 voucher for Amazon. So the stage is yours, Arthur. Enjoy.
Thanks. Yeah, really nice to be here. I'll start by going through the people you will see during this presentation. So this guy here might look a bit familiar to some of you. That's me. Then there's also this person here. She's Eija. She's my fiancée. And then we have this guy here. He's just a generic customer / coworker or someone. And then we also have this guy, who's also me sometimes. Okay, so to the topic. So when was the last time for you when you last time went through your photos? And by photos here, I don't mean your photo album that you have like a physical copy, or photos on your iCloud or on a Google Photos, but those photos that you have taken with a digital camera and you have stored those on a USB drive somewhere safe in your wardrobe a few years ago. And then occasionally you maybe add more photos there. And yeah, I bet quite many of you have that and you have forgotten those. And yeah, we had the same problem, mostly because of this gal here. So Eija is a freelancer photographer. So she's taking quite a lot of pictures of weddings, babies, dancers, models, and whatnot. And yeah, during last few years, she has gathered a collection of around 5 terabytes. I think at the moment we are already going over 6 terabytes of raw photos. And of course, we need to store all of those just in case. And also it would be good to be able to get back to those memories of those photo shoots. So when I moved together with her, I decided that, hey, I can fix this thing for you. I've been doing this cloud stuff for a while, so it shouldn't be that big of a deal. So I said, I'm Arto Liukkonen. I work as a full stack developer or senior developer or lead developer or any kind of developer at Nordcloud. I live here in sunny Jyväskylä, Finland. And I've been doing serverless on top of AWS for the past 5 years. So I thought that doing this cheap and scale backup solutions shouldn't be that hard, because there are quite a lot of these ready-made solutions, and like Google and Apple and all the big players are offering quite a lot of cheap storage. So the business requirements from Eija, so the app should be easy to use, like for non-tech savvy person should be able to use this and upload new photos. It should be cheap, like in a Netflix pricing scale, around 10 to 20 euros per month. Also, it should be durable. Like I didn't want to use any small player, like if you remember, if you have ever used copy.com, that was shut down like 5 or 4 years ago. I used to have a few hundred gigs of data there, and then I had to migrate away from it. And now with even more data, like 5 to 6 terabytes, I don't want to do that process again. And then also we wanted to have a photo browser. So just some web UI where you can browse the photos. Okay, so the first version, first iteration, just copy the files to a network drive at home and then sync those somewhere in the cloud. Okay, so when I asked around and Googled around what could be a possible solution, one thing came up is a Google Drive. We use it here at work, and they offer quite a lot of storage for quite a cheap price. So for individuals, if we want 2 terabytes, it is 10 euros per month. But as we need more, the next tier is 10 terabytes, and it's 100 euros per month. So yeah, just too much. Then maybe Dropbox. Well, for individuals, the maximum you can get from them is 3 terabytes. And if you want more, well, the next step is basically unlimited storage, but you have to buy a team license. So that's 15 euros per user per month, and you have to buy like multiple seats, multiple users. So it goes really over the price that we can pay for this. So as we are in this cloud business, maybe using S3 buckets is the answer. Well, if you store data in a S3 bucket, it will cost you, well, around 2 cents per gig per month. And this is like the regular S3 bucket. If you just create a bucket and upload data there, it will cost you 2 cents per month. So with a 5 terabytes, that's around 115 euros. So yeah, still too much. And also with any of these solutions, as we have raw images from a camera, we couldn't get any thumbnails out of these. And also the galleries would be quite hard to browse because there's just no magic happening there in the background. It will be just a list of folders and a list of files. But even before that, we had to figure out this 5 terabyte storage issue. And yeah, luckily I found out that there is this Glacier deep archive option in the S3. So when you store data in that Glacier, you pay only like $0.00099 per gig per month. So for 5 terabytes, that's around $5. So the Glacier is super cheap. It offers basically unlimited storage. There is, however, a retrieval price. So if you want to get data back, you have to pay for every gig you download. And also there's a retrieval time. So you cannot just press a download and instantly get the file back. Instead, you have to wait for around 12 hours to be able to download the data based on how much data you want to download. But these negative points are not really that bad in our case because this is just for the worst case scenario. So if the home network drive completely fails or house burns down or anything really bad happens, then we have a way of retrieving these raw images. And yeah, there's actually two ways of using the Glacier. So if you go to AWS console, you can see that there is this Glacier vault, or you can use the CLI to create a vault. And if you want to use this, you use the Glacier API. And cool thing with this is that you can actually create a lock that prevents deleting of the objects, even from admins or root users. So for example, for compliance reasons, if you have to store some logs or some information for a long period of time, this is the way that you can make sure that those objects stay there forever or for a specific specified time. But the thing I'm using is the S3 API. So when you upload an object to S3 bucket, you can define a storage class for it. And if you say it's a Glacier, then it will go directly in the Glacier. And what I think about the Glacier Vault, it is just simplified UI on top of S3 Glacier storage class. So this S3 API, at least for me, was much more simple to use. And a cool thing about this is that you can move objects using lifecycle rules from another tier to this Glacier. And I have more about this later, like why this is so good, why you should use these lifecycle rules. So getting back to this cloud backup solution. So we copy the files to the home network drive. Then we put the raw files in an S3. And then we have some magic, and we have a photo browser. To be honest, this Glacier thing, even though it was super simple in the end, it was actually the hardest part of figuring out like how to store for cheap price this huge amount of data. Okay then, so extracting the JPEG out of the raw, so we can actually build the photo browser. So first we upload the raw in the standard S3 bucket. Then we can use exif tool, that is a CLI tool for image editing. So there is within the raw file that comes from the camera, there is this preview image that is basically the JPEG. So we can extract that one. And then we can also extract all the possible EXIF data, like shutter speed and GPS location and anything that the camera provides. We can also copy that information from the original RAW and store it in the JPEG. And then, as we don't need to keep this in an original size, we can use image magic, for example, to resize these images to around 2000 pixels. So those are like a few hundred kilobytes each. And as I said earlier about the life cycles, if you would upload directly to S3 Glacier and then trigger this extract preview process, it would end up costing quite a lot because you would all the time fetch data from Glacier. And that's why you upload first to a standard tier S3, and then after a few days, you can have a lifecycle rule that will automatically move all the processed raw images to the Glacier. Yeah, but then as said, this EXIF tool and ImageMagick, those are like native binaries, native applications. And there is Lambda layers that you could use. There's, for example, there is an ImageMagick layer ready-made that does the job. However, for some reason, I didn't get the EXIF tool working. If there's someone in the audience who have got the EXIF tool working within the Lambda layers and in a Lambda function, especially with the Node.js, then just ping me. I'm really interested. Hopefully I get this fixed at some point. But yeah, at the moment, the process I showed on the last slide just doesn't work. So luckily I have Raspberry Pis lying around at the house. So, and it was already providing like the sync feed functionality for that network drive. So with a little bit of bash magic, we can loop through the folders of raw images and then generate a preview image or like that thumbnail, copy the tags from the original file, and then resize the image. So there on the network drive, we will then have the raw images and the thumbnails ready for us. And then we can sync those thumbnails to another S3 bucket that will be like a regular tier S3 bucket. And here you see I'm using this S3 CMD library instead of regular AWS CLI, and the answer comes later why this was a must-have. So the price for these preview images, well, as said, the regular storage, that is around 2 cents per gig per month. But as these are really, really small images, it will cost just around $1 per month. Okay, so now we have the Raspberry Pi there doing the resizing and syncing. So it will upload the raw file to Glacier, and then it uploads the resized JPEG into regular S3 buckets. But then still missing a little bit of magic here. Luckily, there is this AWS recognition. So they provide face recognition, and so you can find the same person, for example, from different photo shoots. And then there's object and scene recognition. So you can browse the photos by occasion. So you can get animal pictures or wedding pictures or pictures of food or whatever. Here is an example from AWS console. So if you log in, search the recognition, you can drag and drop your own image there, and you can run the recognition from the AWS console. So here we see that there's a good probability that there's humans and persons in this image. There's also water, a handrail, and people are wearing clothes. And then for the face recognition, the same thing, you can run it there. So here's my image. It looks like a face. I'm around that age, yeah. This says that I'm not smiling, but I'm still calm. Okay, and how you run it in your code, it's pretty straightforward. So this is a really simple Node.js example. So basically, you just get the AWS SDK and a recognition package from it. You define the image that comes from the S3 bucket. So you just give the bucket name and the image name. Then you can define like how many labels you want per image and how what is the minimum confidence for the label to be shown there. And then you can just run this detect labels, and it will give you a result for that image. And pretty much the same for face recognition. The only difference is that there is this collection. So you have to create first a face collection, and then same way, give a bucket name, give image name, run the index faces, and then it will return to you back all the data that was in that image about all the faces. And here, for example, in my application, I'm just storing the face ID and then the bounding box. So what are the coordinates for that face in that image? And as I showed you earlier about this syncing those thumbnails, why I'm using the S3 CMD is because of this rate limit. When I first run this like upload script and uploaded everything with a fiber connection to AWS, what I got back was maybe like 2 or 3 images and then throttle errors, lots and lots of errors. And the reason for that is that there is a operations per second quota when running recognition. So if you are running your app in Ireland or US East or US West one, you get 50 operations per second, but otherwise it's just 5. And as we did the detect labels and detect faces, that is running like 2 operations per image. So yeah, you quickly have hit the limits. But yeah, Chipman's solution was that just throttle the upload speed so those images arrive slowly in there. There's, of course, prettier ways of doing this, but this is good enough for me. But yeah, if you have ever watched the Once Upon a Time TV series, you know that all of the magic comes with a price. So does here. So running the recognition costs $1 per 1,000 images. And as we run this 2 times per single image, and we have this 5 terabytes, which means like 200,000, 300,000 photos. Yeah, it costs quite a lot. But as we can store the result in DynamoDB, we have to run this only once, and then also there's a free tier, so you can do 5,000 runs in a month for free. So basically, after the initial run, you can pretty much use it within the free tier. That was probably the free tier for the first year only. So if you have an old AWS account, then I'm not sure can you use that free tier, but still you can always create a new AWS account for that. Okay, so the solution right now. So there's this network drive at home that is connected to Raspberry Pi. So we can basically just mount the network drive within the own OS, on laptop, and then copy paste the files from our machine to that one. Then it will do the resizing and syncing. Then we run the recognition with the help of Lambda and DynamoDB. And then we have the photo browser that is built with the Amplify and React.js. So here's once more the flowchart. So the data goes, oh, this is lagging, okay. Data goes to Raspberry Pi that is doing upload to Glacier, and then also to regular buckets that will trigger the recognition, that will store data into DynamoDB, and then we have this web UI. Okay, and to prove that I've actually built this thing is here. I have added a blur filter on top of these images because these are real customer images and I cannot show these real ones. But yeah, for example, here we can go in this folder, in this photo shoot. Here we see this is the bounding box that we got from the face recognition. And here is the tags. And here, if we want to click on this person, we can see other galleries, other photo shoots where this person has been. And then also all the images of that person. And here we can, for example, click on the label food, and we get all the photo shoots that contains an image labeled with the food, and then all the individual images that are labeled with food. And same way here. Cake. And it's also pretty accurate, as you can see here. There's barely visible that one face there, and same in there. Okay. And that's not everything. I got asked quite often that am I going to put this open source? I've tried. That is work in progress. And number one reason why I haven't is that it is quite tightly coupled with this portfolio website. So for the portfolio website, we have this system where we can put the finalized images that are tagged, and that will trigger a Lambda function that will get those tags from that image and store the metadata in a DynamoDB. And then there's this, the actual portfolio website that I can show here, eiahelena.com. So this is also powered by AWS S3. It's in Finnish, but it's mostly images, so feel free to go there and check it out. And then next step that we would like to do is the web shop, so that there will be a way to put a watermark on the images and have password protected galleries, and then maybe a Stripe integration so people can go there and buy those images from the photo shoot. But yeah, this is something that is probably coming up sooner or later. Yeah, the total cost for this entire solution. I said earlier, the storage in the Glacier, it is around $5 per month. Then running the recognition, well, the initial patch was a few hundred, but after that it's quite cheap, just on demand. And then previews, $1 per month. And then all the rest, DynamoDB and traffic and running the Lambdas, it has been around 50 cents per month. And of course, the time spent on this entire solution, haven't counted the hours, but numerous of hours of planning and coding and refactoring and deleting everything and starting again from the scratch. But it has been a nice process. So yeah, that was my presentation of how I'm storing and browsing a few terabytes of images with less than $10 per month. Thanks.
Hi.
Hey, I was still online. I was just a little bit afraid that has I've been disconnected at some point.
No, actually, I was waiting for Stefan to go online, but I think we lost Stefan. No, Stefan, okay. If you see this, please come back. Okay.
Well, better him than me.
That's true. That's true. Amazing. One question before we go through the questions. What kind of Raspberry Pi did you use? Was it a 3 or already a 4?
Yeah, I think it's 3 at the moment, yeah.
And
so running those photos, it takes quite a while.
I can imagine that.
Maybe it's time to upgrade at some point, but yeah, it doesn't really matter. It's just staying there.
Yeah.
In a shelf and doing its job. So.
That's always good if it still works and you do not run into any heat issues. Then it's perfect. Okay, so the question number 1. I think you more or less answered this at the end. How much time did you invest in this project? Did you also keep track of that? It looks amazing.
Yeah, haven't counted the hours, but yeah, really hard to say. 100, 200.
Oh, it's
maybe.
It was a lot of trial and error, or
yeah,
so, and
yeah, a lot of trial and error, and also this was like one of the projects that I used to learn the AppSync entirely. So I wasn't familiar with the AppSync beforehand, and that's why I've built the solution a couple of times and then deleted everything and built it better.
Okay, and what do you think in this project was the biggest obstacle you encountered?
Well, still the obstacle is doing this fully serverless without that Raspberry Pi. So getting everything running in the cloud. That is the dream. That is the next step.
The next step, okay.
Yeah. But yeah, I don't want to put any containers or EC2 machines doing that job. I want to keep this with the Lambdas.
Okay, and the question which came to my mind sometime in the beginning, and since I'm a hobby photographer, are you afraid that your wife would buy or your girlfriend would buy a medium format camera and the pictures will get ginormous?
Yeah, it might happen.
Okay.
But yeah, it is still I still think it's quite cheap. So like $1 per terabyte.
Yeah.
So those are not that big.
Yeah, it's something you can calculate with. And there is also one question which is something I did not understand quite good. Is, do you generate the web pages for customers on this web page, like private web pages with the images too?
Yeah, that is like the next step. So this was the backup solution. So this is basically just all the JPEGs that you see there are like non-edited, like just extracted from the raw. But yeah, the next step is to have like own website with the ready-made gallery that the customer can then download.
Okay.
And we are using a third party for that at the moment, but yeah.
Yeah, interesting. Is when I first saw your submit of this topic, I was really intrigued by the fact that you would start doing this to like sort 5 terabytes of pictures, because yeah, it's crazy.
Yeah.
Yeah. Okay. So I think we really finally, oh no, Steffen is back. So I can make room for him and turn off my camera again.
So Arthur, from my side, also a couple of questions. The first one is such a huge amount of photos and then creating such a solution. And what I consider the most interesting point is, at this cheap level, was it a trial and error approach? Did you have do such a thing in exact the same way before, or how did you achieve it?
Yeah, well, haven't used Glacier before, haven't used recognition before, and as I said, the AppSync was like, this was my learning tool to learn the AppSync also.
Okay.
So yeah, quite a lot of new technologies for me, but I think it came out pretty well in the end by trial and error.
So I can consider your learning curve was steep.
Yeah. Yeah.
Okay.
Well, of course, I've worked like with the web for like 20 years and with the AWS for 5 years. So not everything was new.
Okay. And from out your experience, because I think this is not untypical that someone uses new services, especially in the cloud platform side. How was the experience? So how well you consider it to be consumed, to learn it, to play with it, just from out your experience?
Well, I think the recognition documentation could be better and the APIs could be better. For example, the face collection, face index, that API is quite stupid, I would say.
Okay.
I've deleted the entire face collection like 20 times maybe, and then run all the data again and again. Of course, I tried with the smaller, just like small subset of data, but still.
Good.
Yeah, but otherwise, yeah, it was pretty straightforward.
So how did you approach it? Reading stuff, or just going directly in the try and error phase, figuring it out, what works well for your use case, what doesn't? How was it?
Yeah, well, trial and error is
Try and error.
Usually my approach.
Okay. Get your hands dirty as soon as possible.
Yeah.
Okay. Yeah. Thought that. Okay. Good. So well, thank you really much for your session here, for the content you delivered. It was very, very interesting. And yeah, well, to the guys outside, you have now again the chance to rate also this session by inserting stars in it. So you can leave Arthur a very good feedback if you like. And also the possibility further on at the bottom of the live stream, you have there Couchbase banner, and by clicking it, you can leave your contact details, and then you are eligible to participate in the game, where you can win 1 out of 3 €200 Amazon vouchers. And last but not least, I hope you stay with us for the last session, which will start in 18 minutes. So 15 minutes after 6 o'clock with Women in AI again. And here, this will not be a normal session. It will be 16-minute panel discussion from the Women in AI. And it's all about, AI again, democratizing AI. And I'm really looking forward to it. So I hope you too, and see you there. Bye.
magnetic fields move and electrons start flowing. When you feel that anything is possible, when the night can turn into day, then a new modern world is possible. Electricity gives impulse to our imagination. Passion and precision are at the heart of our work. Anytime.
Illwerke VKW. Energie für Generationen.
Your app just crashed. It was struck by a hammer manufactured in 2005 by Harry's Hammers. The hammer's head is composed of 75% nickel, 20% steel, and 5% iron. Curiously, a hurricane just came down in Iran.
Hello, everybody. Welcome again to our very last session. It's a panel composed of women from Women in AI Vienna with the panel topic Democratizing AI. And I really like to see what you have prepared in mind, and I hand it over directly to you without, or not without, hinting our audience to the possibility inserting questions on the right-hand side near to the live stream, and last time again of this day using the possibility to participate in the game at the bottom of the live stream with the by clicking the banner and maybe getting one out of free Amazon €200 vouchers. So the stage is yours and have fun.
Awesome. Let me take it on. So hello to everyone. Welcome to our panel discussion. I'm Sanya. I'm part of Women in AI, and we're super excited that we're here. Thanks to WeAreDevelopers for hosting us. We have brought 4 tech experts, really awesome ladies who have various backgrounds, various experiences. But before joining, or like before kicking it off, I actually wanted to also introduce you to Women in AI, what it is and what we actually do and what our purpose and goal is. So I'm pretty sure everybody knows AI is present all over. We have applications, we use it all the time, starting from Netflix or our iPhone and stuff like this. So it's really present all over. But still, it's only 22% of our professionals globally are females. And this is actually why Women in AI was launched as a nonprofit to really increase the female representation and participation in AI. And just recently, we as the Austrian team, we thought about this initiative. Well, we were part of this initiative, but we actually wanted to go a step beyond. We wanted to really encourage the Austrian ecosystem as well to really increase the female representation. And that's why we also launched the nonprofit organization about women in AI in Austria. We're a team of, I think approximately 20 girls or women right now, and we're increasing, a lot actually. So keep posted. I just wanted to give you a heads up what's coming and what's planned for next year. So we had a couple of events this year already, but next year is our main start, or let's call it like this, like our launching sessions. We planned events within the community for female startups, for education. So basically, we really want you to learn and to get insights about AI and freedom of expressions, about an educational stream, about how to use fast AI within the community. So this is also something that we support, but it's also data driven by the data science communities in Vienna. And also we'll have lots of publications as well, where our experts, so we're a global network of 4,000 people, I think, will be sharing a lot of content, sharing a lot of what our participants and members actually are working on and how you can get started with that. But for the Vienna community, we'll have actually a lot of virtual networking lunches bi-monthly. So basically just to give you a little bit of a break of your daily lives. And if you want to join, you're very welcome to do so, no matter if you're female or male. So we're inclusive in that regard, but we really want to give you the opportunity to kind of grow your network and also be able to make sure that in case you're working on something and if you want, I don't know, to receive feedback, to join one of these virtual networking lunches. And of course, we'll do some evening activities as well and have meetups within that space as well. So keep current, keep posted. And now you're thinking, oh, that's really cool, but how to get involved in that? No problem. We have the answer. Make sure to really join us and become a member, first of all, of womeninai.co. You'll probably need to go through a little questionnaire, but after that, you're able to really join our Slack channel, both the global one, but also the Austrian one, where you get involved and informed about future events. And then also make sure to follow us on LinkedIn. We posted a QR code here, so it's super easy to get involved. Just use your camera and then you're gonna be navigated to our LinkedIn page, which is where we're gonna post all future events that we want you to know about, right? This is the Austrian Women in AI team. Thanks again for these ladies that they participated and that they all supporting our vision. And if you really want to become and support us, you can become an active participant. Or if you're a company that also wants to support this vision, you can, of course, become a company partner as well. And our president, Karina, who is going to moderate this session, she will be responsible for that. So make sure to send an email to Karina at womeninai.co. And with that, I'm super excited. Now we can start with the panel discussion. Thanks again to WeAreDevelopers, and thanks for the panelists that they could join and that they made time to really discuss, in my opinion, a really important topic. It's about democratizing AI, and what that means is how can we ensure that people, no matter which background, no matter which experiences they are, but if they want to get started with AI, how to do so. And let me introduce our panelists. We have Nancy Nimes. Nancy has a lot of experiences working in leadership positions of tech companies such as Microsoft and Google. And she also started her digital startup, and she's also the founder of Humanize, which is an initiative to make AI accessible to everyone. She's a great partner of Women in AI and also WeAreDevelopers, and she's also very international. So she's based in Berlin. She can bring into a lot of content from the startup scene as well, I hope. But with that, we're really happy and glad that you're joining, Nancy. We have Linda Mohammed. She has been working about like 7 years in the IT area. She has been working on different or various positions ranging from Java developer to business analyst and product owner. And now she's focusing on emerging technologies. So she's a cloud consultant focusing on emerging technologies, which in my words or my world means that you're focusing on the cool stuff, I assume. Then we have Annalisa Cadonna. Annalisa has been working or worked actually 8 years in academia, and she recently joined the industry tribe, so welcome. She's part of Crayon's AI Center of Excellence as a senior data scientist, and her passion, which I find really interesting, her passion is to generate reproducible resources and also to encourage young women's interest in science and technology. So that's really awesome. She's an active member of the R Ladies. I'm not into R, but maybe I can join to learn something as well here. And I'm really happy that you joined. Thanks for that. And then lastly, we have Katrin Strasser, who is leading the AI department of Cloudflight and is focusing on natural language understanding. So super interesting topic here as well. She actually worked on a lot of AI business application for industries and the public sector. And additionally, she's also an active member and a mentor at Female Coders. So it's a coding group in Upper Austria for women. Basically, I need to advertise this as well. I joined one of their events, I think 2 weeks ago. And since it's virtually now, we can all attend. We don't need to travel to Linz. So make sure to also attend that one. So, and also, by the way, she's part of the Women in AI community and driving a lot of events as well in the Upper Austrian area. So with that, I really want to thank you guys. I think this topic is super interesting. It's super valuable for everyone. So make sure that even if you're not, I don't know, if you don't have a background in statistics, mathematics, or computer science, you can still get involved, and we'll hear about it from our panelists. So with that, Karina, stage is yours, and thanks for moderating. I'll keep an eye on the chat, so make sure everybody who's online to post a lot of questions to our panelists.
Thank you so much, Sanja, for introducing the speakers and for introducing Women in AI. And without any further ado, let's dig into the questions that we've prepared for you, the panelists. And actually, the first thing I would like to ask to all of you, but the first one I see is Annalisa, so I will direct it to you in the first place, is why AI? So why did you decide to go into AI, and how do you use it in your job, and what do you like most about it?
Okay, hi everyone. Okay, why AI? Well, first of all, I come from a background of mathematics and statistics. So what I like about AI is that it allows me to put together a lot of things that I like, right? So mathematics, computer science, but also that is not an abstract thing, but you can really apply to concrete problems. So I would say the problem solving aspect of it and the diversity of the type of problems that you can solve with AI.
Yeah, thank you. That's actually what we've seen also today already with Linda's talk beforehand. So how about you, Linda? Why did you choose to start to kick off this AI project that you started?
Hello, Karina. Thank you very much for the first question. Yeah, so why I started with AI is that I think it's really important to have an eye on historical data and on experience and all of that stuff. And for example, if you look at information technology in general or onto computer systems, then they're usually working with input and output, and all of the things that happened usually are not taken into consideration. But I think that you can learn a lot of experience and a lot of knowledge, and the power of AI is also to connect humans with technology, and I think that's the most important part. And I'm not really into statistics and mathematics, so I think it's really cool that there are different services which you can use that you don't have to think about the statistics behind.
But so now that you implemented your project, maybe you can also just highlight a few sentences about the talk you gave before. Will you deploy it in your work as a consultant, or the findings or something about it actually?
Yes, actually, I can use a lot of things from this talk or from the project in general for my work, because a lot of people are asking me what AI is, what you can do with it, and all of those questions. And it's not really easy to explain it with an example with a real project, because usually you have it confidential and or it's like a really specific subject, so that people don't really understand it that easily. And so it's a perfect showcase to just show the technology, so what you can do with it and how you can approach different problems.
Yeah, very cool, very cool. So Nancy, this brings me to you. So very different perspective. As far as I know, you don't have a tech background. So how did you get into AI? Why did you choose to get into AI? And how do you deploy it now in your work?
Right. Well, so yeah, I did study economics and international business administration. It's very, very simple. Why? So first of all, what is AI, right? AI is just technology. It's just high tech, you know, and for me, when I started to think about my path into the work world, it was about how can I support the technological progress? How can I support people and humans? So the reality for me is really, I want to see the impact of technology on people's lives. And so one of my best milestones in my career was working for Microsoft. And at the time, we were talking about realizing your potential through the usage of technology. And when you look at where we came in the last 20 years, you know, from not even having a smartphone at the time, and now to being able to manage your whole life with this small little device, that for me is the interesting aspect of it. Of course, you have all the technological aspects. Of course, you have the business aspects. But for me, it's enabling people. It's making our lives easier. Of course, there are also downsides to that. But the fact that we can move quicker, we can be more efficient, we can be more productive, we can then take time to enjoy life more, because you can automatize some tasks, and we can think more, which will make us more creative, will make us more innovative. And also the next generations and you guys will be smarter than my generation, because your brain is wired differently. And so for me, it's really about people and how technology can support that. Also with a very important aspect of making sure you understand the challenges in this technology, you understand how to address some of these challenges. We'll not always be able to address all of the challenges, but that's it. And so that took me to several stations. I always was looking for emerging businesses. So at Microsoft, which is a software company, at Google, which is an advertising and search company, I was actually driving hardware businesses for them, things that you never imagined that these companies are doing, because I really wanted to look into the emerging space and how that takes. So for example, at Google, one of the products that we were doing was the voice assistant, their Google Home, which is like Alexa. And so that was one of the first steps in AI, really, to make it widely available through natural voice processing. So that's what I did when I was employed. And what I do today on my own is trying to make this technology available for everyone through education like this and many other things, and trying to drive that awareness so that people understand. Because I think number one issue is that people don't really understand what AI is. Not only AI, but the whole high-tech space. We need to do a much better job about that. So that's my driver.
Thank you, Nancy. So actually you raised many topics that will be discussed today later on. And thank you for providing the not technical perspective as well, because it's very important from a Women in AI perspective to bring together interdisciplinary know-how and exchange point of views. And so last but not least, Katrin, please give us your perspective. How did you get into AI? Why did you choose to get into AI? And what do you love about your work with AI? What makes you smile at work?
Yeah, so how I got into it was actually more or less a coincidence, because I decided to study bioinformatics in the master, and I did this in Linz. And turned out that study was actually mostly about artificial intelligence. And yeah, now I'm really glad about it. It was different than I expected, but I'm still glad I did it. And yeah, now I'm also working in this area. And what I really love about it is to solve specific problems. So usually there is a very specific problem that cannot be solved otherwise. And very often the solution is there in the data. So it's there and you know it's there and you have to find it and build a model how this information can be read out of the data and be used and be actually turned into human understandable information. And yeah, that is what made me stay in this area, these challenges and always something new. And yeah, what I also love is to just analyze a bunch of new data. So it's always great when some new data comes in.
Yeah, very cool. Actually, let me stick with you, Katrin. So you said that you really like this idea of getting information out of the data, solving the problem. So how would you define AI? As there is not one agreed definition. So for you, what is AI, and what does it mean to actually democratize AI?
So how I would define AI is that it can support with very specific tasks. So I wouldn't see it as a general thing that can solve everything, but AI has to be designed for a very specific task. And what I see as democratizing it is to make people understand what AI actually is. Because there is a lot of misunderstanding from movies and so on that, AI is very evil and will destroy humanity. But that's not what it actually is. And it's still a tool and we use it and we can develop it in a way that it's also used for good. So I think it's important to get that understanding more to the people.
So, okay, great. So a tool to actually solve specific tasks, but not to solve every single problem in the world. Anyone else who would like to add on that, please just jump in and let us know how would you define AI and what does it mean to you to democratize AI?
Yeah, I'm happy to do that because this is one of my big passions as well. So look, I mean, the more people you ask to define AI, the more answers you'll get. And this even led me to publish a book which includes a lot of questions around how to define it. If you go to the deep tech experts, they will tell you it's really about deep learning models, machine learning. If you go to the humanistic specialist, you will get a broader definition. So for me, it's really at the end of the day, what we try to do in these computer systems is that we try to simulate human intelligence. So we try to use machines, just like we said earlier, with voice assistant to kind of simulate intelligence. You ask Alexa or you ask Google Home a question and they give you an answer. It's funny because I asked 22 experts in my book, which is called the Proust questionnaire. I'll show you on purpose. I made it kind of interconnecting humanity and technologies, because you need to really understand how the human brain works in order to do that. So if you want to program machines to think like humans and mimic their actions, then we need to understand the human brain even much better than we do today. So I have 22 experts here. I asked them all from different disciplines to give us a definition of AI. And I got quite different answers. So that's the number one aspect, right? However, problem learning and problem solving, these are two of the most important areas that should be part of the AI definition, right? So how can you create machines that exhibit traits associated with the human mind, right? So that's one aspect. And then I would say the second aspect is how to democratize AI is really by making it available to everyone. That's clearly one of the most important elements. But also, as you look, many leaders are trying to do that today. Many people are trying to look at the tools and knowledge and the data that they have in their companies and understand how to drive innovation. And I think democratizing AI has to do with efficiency improvements, has to do with the business aspect, has to do with the societal aspects, has also to do with how do we create the right talent. This is democratizing AI for me, is to have a very diverse base of talent. We show a great example here, but we still very little women, for example, in AI. There are many other minorities or other specific society groups that are not represented yet in AI. So I think it belongs to the democratization story that we look from different angles, from the technological, business, and human aspect, and then really try to drive efficiency. And as we create these tools and improve people's lives, as we said at the beginning, that's when we can say, all right, so now it's largely available. Not unlike what we have today with electricity, what we have today with cars. Everyone can have a car, most everyone in the developed countries can afford to have a car, can afford to have electricity, can afford to drink water. And that was a very long way. And I just want to make sure we know that this is equally a very long way. We are at the very, very beginning, just scratching the surface of what AI can do. And so we will see a lot more coming up. But as you think about democratizing AI, it's really also think about how you follow human progress. What's the path to human progress? And in order to do that, of course, one of the big cautionary tales is that even the most sophisticated AI systems that are designed by very, very well qualified engineers can fall victim to bias. I know you'll ask about bias later, but that's also an aspect of democratizing, is like, how can we explain how these machines are acting and how can we avoid bias?
Yeah, thank you, Nancy, for that answer. I think, I couldn't agree more. And to everyone who's interested, check out the book. Maybe you can show it one more time. And
happy to do it. It's 22 experts, of which 11 are men and 11 are women. Great. Design. And 22 experts from very different disciplines, including philosophers, anthropologists, business people, tech people, doctors, and so forth. They answered 22 questions about AI, which I wanted them to answer. So, yeah.
Great. But as it shows also, the definition of AI is not that simple. So I'm not sure. But Annalisa, Linda, would you like to give it a try from your side as well?
Well, I believe, we know that different. So the definition is in the general AI would be what we imagine, right, as a futuristic thing, and then what we see in movies like Hair or Ex Machina, and this is not where we are now. And in my opinion, we need to think carefully if it is where we actually want to go, right? And for now, I agree with Catherine that AI can be used for very specific tasks and to solve very specific problems, but it can never be separated by humans. I think democratizing AI starts from education and literacy, from data literacy and also understanding what big companies can actually do with our data, because I see most people think they just steal our data and have our info, but it's not that. They're actually using it in a certain way to predict our behavior. And so I think the understanding and the education is the first step, because this is happening all so fast that we just got understood how a computer works and what a computer is and why we type in a computer instead of a typewriter, and now everything is changing again. So this is my opinion.
No, totally. I would just absolutely agree. And I would say, really, how do you make this technology accessible and affordable? Right now, it's not cheap to do AI. So as we think about democratizing, we have to think about accessibility and affordability in both areas.
Very, very true. So,
but I think, can I add something here for the business perspective? I think that's really interesting that many companies think that AI is too expensive for me, because actually it can help to solve problems easier, for example, in a shorter time period and in a better efficiency and everything like that. So of course it needs a little bit of time and also costs to implement AI into a business process, for example, or to solve a problem. But in the end, you will win because you win time, and as Nancy already said, you can make your people more creative because they have the head free for other things.
Yeah, very.
And I think that has to be.
Yeah. It's a
maybe just if I may just one, because this fits exactly to what you just said. Like you know what? Like, what is democratizing AI? We could go really now deep into semantics and say, what do you mean by democratizing AI? Is it that something very simple where you say, okay, we want to do data visualization? Or do you want to say it's more complex, where you say, okay, we want to develop a model that is democratic, all-inclusive, unbiased, etc., who the users are, you know, how these organizations can maximize their benefits. So every leader, I believe, in the world that's looking to drive more democratic AI types has to really understand first, to your point, is like, what is the purpose? Why do I need AI? And once you understand the purpose of why you need AI, it will be much easier to ask the right questions to come up with the right business models.
Yeah, I also personally, I agree. I think there's a lot of disinformation also from the business perspective. I always hear these stories of companies just gathering random data and looking for someone to do something with it without having a goal in mind or even understanding what AI can do and what not. Yeah, maybe also, Linda, if you would like to add your final definition of AI in this regard.
So yeah, for me, AI, I would define AI to be somehow a simulation of human intelligence. So as Nancy already said, it's like trying to put intelligence onto machines, and that's what AI is for me. And one of the concepts which I had a look on is, for example, machine learning, and that's exactly what it is about. So you're trying to simulate humans or simulate the human intelligence with the help of different statistical methods or processes. So when I approach a problem which I would like to solve with machine learning, then I'm thinking about, okay, how would I approach this problem as a human? And then I'm trying to build this process in a system, for example.
Okay, great. So actually, we managed to come up with kind of a definition for our panel, I would say. So we have twice the thought that AI cannot solve every random problem, or it's rather a specific targeted problem that we are solving. And on the other hand, that actually AI is a simulation of human thinking. So we're trying to simulate the way we are constructing or reasoning. Perfect. So now that we figured out that, so why, if we say it's only to actually solve very narrow problems, so why is there all this talk about this huge potential and huge challenges of AI? What do you think? And in this regard, I would actually, stick with you, Linda. So that's my favorite topic, by the way, AI for society. So what do you think is the potential and the challenges for AI?
I think there's a great potential on connecting humans with technology because, yeah, AI is more or less the connection of the dots. And I think that's the most potential we have. But I think that education is really important here because people think that AI will take over the world, and also, like Katrin already said, in movies, it's displayed like really differently, like it is actually. And yeah, I think that this is really a huge problem that
So,
people don't understand it.
Yeah. So you think, if I understood correctly, the biggest problem is actually the disinformation about AI and the fear it creates and the rejection that comes with it. So Katrin, as Linda already actually mentioned you, how about you? What do you think are the big potentials and the big challenges of AI?
I'd like to start with the challenges. And I would come back to the general understanding of it, because it's not so easy to train, for example, a machine learning or deep learning model in the correct way. So you have to think of many things like how to evaluate it, how to split the data, and so on. And very often people throw around with numbers. So we have 90% accuracy and everything sounds great. But in the end, it doesn't really mean that it will work well. So there are many things you have to keep in mind as a developer, but also as a customer, because when you buy something and it sounds good at first, but then you wonder, why doesn't it work? Yeah, so it's not always easy to get a good model out. And yeah, this is definitely one of the challenges, to develop it correctly and also to understand what can go wrong there. Like, for example, the bias that was mentioned before.
That's a good word, yeah. And the opportunities?
The opportunities.
Especially thinking of AI for good, for example.
Yeah. So basically, I think there are many ways that AI can support people and also can be used for good things, like, for example, making sure that there is less CO2, I don't know the English term for it, but less emissions, like to optimize processes, that there are less products that have to be thrown away and so on. So it can be used for good. And yeah, I think there is a lot of potential for it.
Yeah, great. Perfect. So Nancy, I know bias, that was your word. So I will hand over to you. How about you? How do you see the potential of AI for good for society, and also what are the limitations / threats in your opinion?
Yeah, thank you so much. And also I will have to leave after this question, but thank you for this question, love this question. Okay, so like potential. You know, I like to think about the big areas, right? We can take now examples by industry, by, you know, type of work we want to do. But if you look really at the end of the day, the potential is to enable humans to concentrate more on meaningful work. So just like we saw with the Industrial Revolution, today, we do not need to work with our hands that much anymore. We do not need to do very strenuous physical work anymore, good and bad in a way, right? It forces us to have a different lifestyle so we can cope with this new world. And so that's the same. What is the potential for AI is really to enable us to become more creative, more innovative, because we can concentrate on meaningful work. We can let the machine automate the tasks that it can automate. So we can then, at the end of the day, probably also enjoy our life and have more fun in our life. The other thing is like, also, I think one of us has said before, is like, how can we help humans and machines to work together? There is a huge potential into this augmentation, which is why, again, back to the definition of artificial intelligence, that really deep tech people do not like that word, artificial intelligence, at all, because it's actually very confusing and misleading term. Some like to use augmented intelligence. as a definition for this space, because it basically means humans and machines augment each other. Basically, the machine should augment me. And so that means really what's the best way possible. This is the potential. And then you mentioned a lot of areas that completely agree on in terms of challenges. I would just want to mention maybe just three, which I think are really important. Number one, which you just asked me, was about bias. So that's a very big problem, the bias problem. So the solution to drive good AI solutions, basically, in future is to have good data. So you know, the data that we have many, many times is crap. So if you want to have good AI solutions and drive AI for good, you have to have quality data. If you have bad data, you'll have a bad AI. In reality, also the data that organizations are collecting is really not only not good enough, but it's also biased. Why? Because we do not use enough people with different backgrounds. And it's coming back to the bias issue. We need to really connect, across religion, ethnicity, gender, cultural background, language, community. So it's not just about gender or just about one aspect. It's really making sure we build teams that reflect the society. So that's number one. The second one I wanted to mention, which I don't know, probably hasn't been mentioned yet, is we need infrastructure. We need computing power. These whole algorithms, are very power hungry. If you want to drive data, if you want to drive deep learning and machine learning, you need very strong GPUs. You need processors. You need cores. They need to work efficiently. And as you know, supercomputing is the next big leap, and they are not cheap again. So infrastructure and computing power, very important. Is also the reason why we're still at the scratching surface in this space. Bias and the whole story around trust and all of that is the second most important. We already mentioned education, awareness, and so forth, but I want to mention one that is really important, which is today, and it will be like this for a long time. Humans will always do better than algorithms at prediction. And as you know, prediction is one of the key areas to drive, machine learning, deep learning. We know that in 99% and more of the cases, a human can predict better if it's a cat or a dog when you do image recognition, right? So even after you train your deep learning model with hundreds of millions of data sets of images of cats and dogs, very famous example, even if you fine-tune that machine for the maximum accuracy, today they still show errors. And they will struggling and they will be showing errors, and they will never, in my opinion, that easily go to human level performance. This is a very broad, very simple example, but there are many, many others. So in my opinions, prediction and predictive models, there's a huge opportunity there to improve, and one of the challenges we have today.
Super, very interesting. So there are two things that come to my mind. Also, the computing power is linked to a lot of challenges for our environment, because all these server centers obviously use a lot of energy. So there is a lot of discussion coming today about what actually machine learning, deep learning means for our environment and for emissions and so on. And then I just wanted to ask to the crowd, so does everyone agree, or would someone contradict about the predictions, actually, whether machines or humans are the better predictors? Only out of curiosity.
Well, I think the main difference is that machines need so many data, as Nancy said, millions or billions of data to do a simple prediction, while a kid can see an elephant on a book and then recognize an elephant in real life. This is not going to happen with a machine.
With a machine so soon, yeah.
I would slightly disagree because I think it heavily depends on the tasks. So cats versus dogs is quite a simple example, but there are many tasks where you need top experts to predict something or to classify something. And in that case, the model is maybe not better than the top experts, but better than the average human. And in many cases, this is already an advantage.
Okay, just to say goodbye to Nancy. Nancy, thank you for being here. It was great having you, bringing your know-how, expertise, and experience.
And I hope to see you very soon with the community in another event.
Thank you so much. You guys are doing a brilliant job. You know, I'm just very, very happy with how you put this panel together, very diverse. And so thanks for having me. Great questions, and see you soon. Thanks.
Bye-bye, Nancy. Bye.
Karina,
So, yeah.
I'll actually use the break in between. We have actually a really good question from the audience. Actually, there are a couple of, but this one kind of relates to the topic. So, will democratization of AI help with the trust in technology?
I would direct this to Annalisa because actually I didn't manage to ask her beforehand. So Annalisa, if you have an answer to that.
Oh yes, I do believe so. I do believe trust is one of the main issues in AI. And I do believe democratization, meaning helping people understand what's going on under the hood, will help with trust. And also helping people understand what is possible and what is not possible. On the other hand, I also believe we should make AI more, like we should, together with the model, we should give an explanation.
And Annalisa, do you think that deep learning models are explainable?
I'm a statistician. I'm gonna tell you no, but I do. So I'm a fan of interpretable models. So we build a model based on our understanding of the problem. But explain deep learning model is better than not explaining them.
How about you, Katrin and Linda?
So very often you cannot like fully explain it, but as Annalisa said, you can interpret it. So you can say, okay, this was maybe predicted incorrectly because of this and that. So you usually know the data and know how it behaves. But in the end, it's just an interpretation, and you cannot say for sure. But very often this helps to still improve the model and to use this knowledge to make it even better. But yeah, I fully agree that together with the model, an explanation should be delivered.
To answer this question, I would need to really know in detail what deep learning is about, but I'm still scratching on the surface on this topic. But but I think that you can explain it if you know which data you used and how, like in which workflow you use the different data. And I think that's really important. And yeah, I'm happy to hear your opinions about deep learning, because I got one question in my presentation beforehand, and somebody asked me whether computer vision is declared as deep learning. So maybe you can help me with explaining that.
Any expert can jump in. I see Katrin is unmuting herself.
I would say most of the models used nowadays in computer vision are deep learning models, like convolutional networks and
Usually, but there are still algorithms that are not considered deep learning.
What I learned as a non-tech person is that basically there is a big part of the community agreeing that deep learning is basically neural network, like you can use the two terms in a similar way. And I think the problem is that you have actually the model figuring out itself how to structure the data, and you cannot always transparently see into it how it's actually structured.
Yeah. So maybe it learns from something that you didn't expect. That can happen, that it doesn't learn the cat, but how the background looks like, because all cat pictures have a similar background. That could happen, for example.
Or the snow example, where you think you can distinguish a wolf from a dog, but in reality the attention was put on the snow, and if a dog is in snow, it actually thinks it's a wolf.
Yeah.
But okay, so Sanja, I would hand over to you for the questions from the chat.
Perfect. So actually we have two questions relating to references or recommendations about any learning materials. So the question is, what is the best way to start a course of a data science or AI fundamentals for women? Any platforms for reference, please? So I think that's actually good since we have 2 data scientists and 1 developer using AI. So maybe we can just like split it up and see it within different areas or perspectives as well.
Or may I actually just say, like, for a complete newbie, like I started as a non-tech person. The first course I saw was AI for Everyone by Andrew and G on Coursera. And then I just started to dig one after another, getting different parts, but that's the complete newbie part actually.
So I guess you can also type it in later, like once we're done in the chat, so that everybody can join. Whoever is new to AI and really wants to start from the scratch and really understand the whole concepts around it, but also I guess some kind of business impact as well in that sense. Let me see. There's another question. What area of AI do you recommend to specialize, like NLP, computer vision, or something else? And maybe the others can also add some references that they are having in mind to the audience, just like because those 2 are really related.
So regarding the references to learning, I think the question is interesting because I cannot really recommend something for men or women. I think that everybody can learn from the same sources. But I personally use Udemy a lot for learning new technologies. And I think that also A Cloud Guru has really good resources on, for example, everything around cloud technologies. And they also have a course regarding machine learning, and that's really cool. So I did this course, it's like about 40 hours or something, but it's really cool. And regarding the other question, so which area would you recommend? I think that really depends on the problem you would like to solve. So if your problem is a lot of data which you just have in a voice format or something, then you can think about speech to text and then doing NLP stuff. But if, for example, you have problems which you can solve with sight, then you should use computer vision, because then NLP doesn't really help you with solving the problem. So it really depends.
And also on what you like, right? If this is about learning, on what you find most interesting.
Absolutely.
Yeah, I have one addition to the sources. I can only totally agree on these online courses, but there's also one blog I really like. It's called Machine Learning Mastery. And it has also a section for how to get started. And it's very helpful because there are many terms. And you have some intro, some terms how to start with. And in the posts, there are also code snippets provided. So that helps me, for example, a lot to understand it better than just formulas. So if you're more the code person, then this is also nice to look at.
Also, maybe if I can also add something, what I'm doing is I like to use LinkedIn Learning a lot because it has really like short videos of, I don't know, like a whole course lasts for 3 or 4 hours, and it's really like on point more or less, which is also really interesting that you can then identify the people who actually did the workshop or like did the course. And then what I do is either, I don't know, add them on LinkedIn and follow their feeds or whatever they're posting and learn through that as well. So do you ever, like all the time you're getting new things or like new words or something that is kind of connected to that. And also just like, I don't know, I like reading blogs. I think Medium is a super resource where they kind of explain several things in that part. So this is also something that I would recommend in the end. So whatever, as Annalisa said, whatever is interesting to you, go ahead and kind of research. I mean, in the end, I think Linda said it as well in her talk. whatever problem you have, you just like, I don't know, you start Googling it, you start researching about it, seeing what others have built up. And my opinion is, if it's out there, don't start from scratch, but rather use the work from others. And I think Annalisa, she is the one generating a lot of reusable content, as we said. So make use of that, and then just like build up on the other work as well, since this is, I think, anyways, like the whole goal and vision of open source as well, right? To kind of develop once, like after and after whatever other people have built on that. So just to add my 2 cents on that as well.
And join the communities, like try to build up a network of like-minded people trying to actually also learn something. So I think it's very helpful to have a body to learn certain things. So I think that's very helpful. And join our networks. And also we are launching a super cool course together, as Sanya mentioned, in 2021. And we still have to figure out the details, but basically it's going to be based on the idea of Fast AI, which is a free online course from Jeremy Horowitz and Professor Thompson, I think in University of San Francisco, so fast.ai. And we're going to try to rebuild it together with some other communities. And I think that's a very good way also to get a bit into it. And we will keep you posted about that topic on our LinkedIn channel and other channels. Yeah, so are there any other questions, Sanya, from the audience?
No, I'm just smiling because somebody wrote, is that an IKEA Pax wardrobe? And yes, it is in the background. So just as an... I mean, there's one other question, sorry, I overlooked it. Is AI the only multidisciplinary science at the moment?
Human rights, no, sorry.
Well, how is multidisciplinary science defined?
Let's see, whoever posted the question, if you want to add some more details on that.
I think you can explain that with just mixing up different areas of expertise or areas of knowledge. Like, for example, you need a, what is it called? Cross-functional? Oh, HL. You need a cross-functional team to solve different problems, because if you, for example, have just an iOS developer and you would like to have different devices supported with your application, and yeah, then you just need different people. I think that would be somehow the definition of multidisciplinary science.
Yeah, I would totally agree to that. Actually, I think that's what it's all about. And that's actually what I think is meant, that in the sense, in order to get good outcomes from AI, or not even from AI, because think of business. I mean, there are so many reports saying that diverse teams perform better. And I think diversity is not only meant in the sense of color or gender, but also in the sense of having different backgrounds come together. And I think that for actually having a training a model to take decisions, to make it robust and reflect and take fair decisions, actually, I think that you need exactly to have this interdisciplinary approach. But I think from my limited perspective that actually there are many disciplines where it's good to try to get more diversity and reflect different points of views. Yeah. So actually, if I'm not sure if somebody would like to add, but if not, I see that we are coming close to the end. So we still have a few more minutes, but what I really would like to ask you is why actually, like, to take a female perspective and just reflect, like, why would you encourage other women to get into a career in AI?
I guess if you want to do something for everyone, it needs to be done by everyone. So there needs to be a different, like, there need to be different perspectives. So diversity is key. Otherwise, we are gonna always target the same group of people. Yeah.
Thank you.
Yeah, and also there are so many different possibilities in the AI area. So you don't have to be a technician to do AI. It's also important in law, for example, that, yeah, this technology is at least a bit understood.
But
and
also, if you're a woman and you want to be technical, just go for it.
Yeah, of course. That's also great. It's a lot of fun and very different tasks every day. And yeah, it basically never gets boring.
I think in general, women should do more technical stuff and don't be afraid of all of the guys in technology. So I have no idea why it's a problem to be in tech for women.
I think as well. There's so many cool things. I mean,
at some point it's normal for me, and I guess for you too.
We're just humans, like all of us. It's like there's no difference. Everybody of us is working in the same way. We're all learning, and yeah.
But so very interesting, Linda. So for example, did you did you know you're gonna go into a technical profession when you were very young already, or when did you decide?
Yes, actually, I decided like really early to go into a technical direction. But for example, in Hauptschule, it's called in English secondary modern school, or I don't know, something like below high school. When I wanted to go for technisches Werken, so I need some help with the vocabulary. But like I wanted to do the technical stuff and not stuff with rule, like I don't know how to explain that. And actually I had to talk to all of the teachers, and also my parents had to come to school, because the teachers were asking me, yeah, but if you would like to work in a field where only women can work, then you cannot do that if you want to go in a technical direction. And I'm like, yeah, but if that's my point of interest, then why not?
I mean,
but I had to explain a lot.
Where the problem comes in, that you're disencouraged or encouraged in certain directions. And yeah. So I'm not sure if anyone wants to add. Otherwise, I see Steffen, and I think that's a certain sign.
You are guessing correctly. So, but any final words on your side you want to place?
Let me just thank everyone for being here. Thank WeAreDevelopers for having us on this very cool We Are Life Week. And I would like to encourage you all to check out womeninai.co. Join our, no matter where you are, who you are, what you are, just join our network and connect with all of us on Slack. And if you really want to get engaged and say, that's so cool what they're doing, I want to share my know-how, I want to help organize events and so on, then drop me a message at karina@womeninai.co. And otherwise, thank you so much, dear panelists and Sanya, for setting this up and for making this happen. Yeah.
So then also from my side, a really big thank you to all of you. It was a very engaging panel discussion, and a lot of great input I gathered from out of it. So I liked it, and I think the audience too, because the amount of questions is basically at the top of the whole day. So that's a strong sign, yeah, that they have the same impression as I do. So at the end, now we are at the finishing line from this Data Works Day 1 at the WeAreDevelopers Live Week. So just to wrap it up, what we have seen today is really a broad mix of companies, people, topics, etc., with I would say a diverse range of topics, sessions, talks, panel at the end. And I enjoyed it, being your hoster, your moderator. I thank WeAreDevelopers, so also Stefan and his team, for having us as also the day hoster. So Couchbase had a lot of fun today. I personally enjoyed it. And this week is not over. You see here, we have tomorrow scale, the web future, quality is the MVP on Wednesday. On Thursday, you have building software. And also on Friday, you have user in the focus. So the week is still further on fully packaged for you guys. And I bet you will stay with WeAreDevelopers throughout the week. Again, from my side, thank you for your attention. Thank you for being with us. And yeah, have a good evening. Bye, guys.
Oh, hi. So you are still here. That's good. Also, a big thank you. And
Hi, thank you. It was great working with you once again. Super cool.
It was always fun.
Bye, ladies.
Bye. Thank you for everything.
Bye.
Have a good
Welcome.
So, I just wanted to add three things. Number one, thank you, Couchbase, especially Stefan, for guiding everybody through the day.
Welcome.
Big round of applause for that. And also, we will be back tomorrow at 10 with another workshop. And this time, it's not a workshop, it's a startup pitch. Okay, you see, it's a long day and we are already tired. No, it's a startup pitch, so if you are interested, also go and register yourself to join live and represent your company. And number 3 of the 2 things is something which is very, very important for me personally. The DaVinci Labs Kids coding is nearly sold out. I think there are 2 slots left. I think it's either Thursday or Friday. So if you are still thinking about Thursday or Friday, last chance. But they will also have an update tomorrow on their webpage regarding the courses they will hold in December. So if you want to treat somebody who is between 9 and 17 or 9 and 16, 9 and 17, this would be a really cool Nicolo for those of you who speak German, or maybe even something for Christmas. So that being said, I will wish you a good night and stay safe, and see you tomorrow at 10. Bye.
magnetic fields move and electrons start flowing. When you feel that anything is possible. When the night can turn into day, then a new modern world is possible. Electricity gives impulse to our imagination. Passion and precision are at the heart of our work. Anytime.
Illwerke VKW. Energie für Generationen.
Your app just crashed. It was struck by a hammer manufactured in 2005 by Harry's Hammers. The hammer's head is composed of 75% nickel, 20% steel, and 5% iron. Curiously, a hurricane just came down in Iran.